In the silent ocean of space, beyond the reach of our sun's warm light, the galaxy reveals itself in a gentle shimmer. Countless stars glint softly like distant candles in a sea of dark velvet. We drift here, weightless and unbound, listening to the quiet hum of the cosmos. Time flows unhurried, as ancient as the starlight that surrounds us. Our journey carries us across the vast, calm void, toward worlds unknown, yet beckoning with faint light. Far from home, we glide through interstellar night, leaving behind familiar constellations. Around us, a gauzy band of the Milky Way stretches from horizon to horizon, a cradle of billions of stars. Each star holds its own secrets, with planets circling in silent orbits. We are wanderers among these stars, moving as if in a slow dream, guided by a whisper of curiosity toward the faint glow of a nearby sun. Ahead, a dim ember of crimson appears against the darkness. The nearest star beyond our solar system, Proxima Centauri. Proxima Centauri is a tiny, cool star, an ancient red dwarf with a subtle flicker. As we draw closer, its red light grows from a pinprick to a pale ruby orb, casting a dusky glow on the surrounding space. This star's light is gentle and strange, carrying a warmth tinted with hues of rose and ember. Proxima's brightness is much weaker than our sun's. Here, even day might feel like perpetual evening. And circling very close around this dim star is a small, dark world. Proxima Centauri b, our first destination on this cosmic voyage. We descend softly toward this distant world. Proxima b hangs before us, half in light and half in shadow. One hemisphere faces the red dwarf in unending day. The opposite lies in eternal night. The planet is tidally locked, forever turning one face to its sun, as if offering itself to the light while keeping its far side in quiet darkness. We slip into orbit above the twilight edge, where day meets night in a gentle gradient of luminance. Below us unfolds a landscape caught between two realms. On the day side, beneath the dim red sun, the land is bathed in a coppery glow. The sky above is a deep burnt orange, the colour of a perpetual sunset. Long stretched shadows of rocks and ridges paint the ground, never moving, frozen in the endless day. The star Proxima hangs fixed in the sky, a dull red disk that neither rises nor sets, but simply hovers. Its light is soft and diffuse, turning the horizon a dusty rose and the ground to shades of rust and umber. It is a cooler, darker light than our sun's, less blinding, tinged with the colours of twilight. The terrain beneath that ruddy sky appears barren, yet serene. Rocky plains of dark reddish stone extend toward a hazy horizon. Here and there, faint glints might suggest patches of mineral-laden frost or dried salt, catching the low light. If liquid water once carved this land, it now survives only as a trace of moisture in sheltered craters, or a thin mist that hugs the ground in the star's gentle warmth. The air, if one could walk here, would feel still and thin, barely whispering across warm rocks. In the distance, low hills shimmer under the eternal afternoon, their slopes illuminated on one side by Proxima's steady glow, while their far sides lie in utter black shadow. Moving our gaze toward the night side, we watch the landscape disappear into darkness. The terminator, the line between day and night, curves across the surface like a gentle, unhurried wave, a never-fixed band of dawn and dusk. Along this twilight zone, the world is caught in perpetual evening. The sky above fades from dusky orange to deep purple, and finally to black as one looks from the day toward the night. Stars begin to emerge overhead where the sky darkens, while behind us, near the dayside horizon, a faint copper glow still persists. In this dim belt of eternal twilight, one might find the most temperate regions of the planet, a land neither scorched by endless day nor frozen by endless night, but balanced in between. Perhaps in this narrow, dusky realm, a whisper of wind stirs. Warm air from the light side, heated by Proxima's face, flows slowly toward the frigid darkness, creating a gentle, ceaseless breeze that runs from day to night. We imagine standing at that threshold. To one side, in the west, the red star hovers low, painting the sky in peach and bronze tones. To the other side, in the east, a canopy of stars has already unveiled itself in the indigo twilight. Overhead, the sky is a gradient of muted firelight and night, shades of maroon and violet blending like watercolours on a celestial canvas. Underfoot, the ground is cool and firm, perhaps dusted with frost carried on the breeze from the night. In places shielded from Proxima's light, delicate ices form, crystals of frozen air or water, gleaming faintly in the perpetual dusk. Tiny facets catch the ruddy light, sparkling on the shadowed sides of boulders, like distant stars that have fallen to the ground. The air here is colder, and if one could breathe it, each breath would be crisp and thin. There is a profound stillness, no obvious signs of life, no rustle of leaves or scurry of creatures. Only the soft sigh of the wind travelling endlessly from the light into the dark, as it has for eons. Now we turn fully toward the night side, gazing into an endless abyss of darkness. The far hemisphere of Proxima b is a realm of permanent night, a face of the planet that never sees its sun. It is cold and still, perhaps coated in ancient ice, the final resting place of water and air that have drifted into the eternal freeze. If we drift above the night hemisphere, at first we see almost nothing, a black expanse, faintly outlined by a dim red crescent along the edge, where a little light from the hidden star spills around. But slowly, as our eyes adjust, subtle details emerge. Above, the sky is ablaze with stars. With no sunrise ever coming, the heavens remain a permanent tapestry of starlight from horizon to horizon. The Milky Way's band glows magnificently, a river of light crowning the endless night. The constellations here are unfamiliar, shifted by our voyage to this far vantage point, yet they shine even more crisply than on the clearest earthly night, for no nearby sun competes with them. Among these stars, 2 points of light stand out from the rest. Far away, the twin suns of Alpha Centauri A and B, the other stars of Proxima's triple system, glimmer together as a tiny pair of adjacent dots in the sky. They are distant, but brighter than most stars here, a reminder of a family of stars across the void. Beneath this stellar canopy, the landscape of the night side lies in near complete darkness. If there is an atmosphere, it might manifest as a faint haze or a sheen of frost on the ground, visible only by starlight. Perhaps at the magnetic poles of this world, tenuous auroras dance, silent ribbons of green or purple light, born of Proxima's sporadic flares, shimmering faintly above the dark, frozen terrain. These would be the only moving lights on the night side, ghostly curtains waving on the horizon and then vanishing. On the ground itself, a layer of ice and frost likely covers everything, like a dusty snow, reflecting the scant starlight weakly. Craters, if they exist, and the outlines of mountains are hard to discern, except where they block the starfields or catch the glow of an aurora. It is a world in slumber, locked in a deep freeze that has lasted millions of years. Here, time seems to pause. Without day and night, without seasons or weather, change comes on the slowest of scales. An accumulating coat of ice, a rare meteor carving a fresh crater, the almost imperceptible creep of a glacier. Though stark and inhospitable, this eternal night holds its own tranquility. We float for a moment in the silence above the frigid surface, where the temperature has plummeted far below anything we know on Earth. All is hushed. Without sunlight, even wind dies down. Only a faint, creeping flow of air may exist, sliding from the twilight toward the coldest heart of night. If there were an atmosphere, it could be pooling here, freezing out into blankets of carbon dioxide or nitrogen ice. In the utter stillness, one could imagine that even sound might refuse to travel. Yet perhaps deep below, this planet still has a warm heart, a molten core that sends up occasional tremors. Maybe far beneath the miles of ice, there are hidden reservoirs of liquid water, warmed by the planet's internal heat, potential oases of life entirely cut off from the surface. If life exists here, it might be confined to those secret caverns, living out its eons in total darkness, oblivious to the stars overhead. Gently, we turn back toward the light, and the Terminator line comes into view again. That delicate boundary of perpetual dawn and dusk. This narrow region, circling the planet between day and night, could be the most welcoming place on Proxima b. Here, in the soft half-light, the temperature might be just right for liquid water to briefly exist. If some hardy life clings to this world, perhaps it is here that it finds a foothold. We imagine, in the dim red glow, maybe patches of dark, slow-growing lichens crust the rocks, or a thin film of algae grows on the underside of translucent ice, where day's warmth meets night's cold. Maybe there are shallow subsurface pools that thaw a little when Proxima flares and then freeze again. Within them, microbial life might stir during the mild spells. It would be life at its most tenacious, enduring long freezes and feeding off minerals, the weak sunlight, or the energy of occasional stellar flares. Above this twilight land, the sky is a study in gradients. Low toward the day side, it glows a faint burnt orange. Opposite, on the edge of night, it is indigo and sprinkled with the first stars. Overhead, a few bright stars and the ever-present double dot of Alpha Centauri pierce the twilight. The stars here don't twinkle much. Proxima's thin atmosphere, if it has one, is likely calm and clear in this region, without the robust weather of Earth to make the stars dance. It might be so clear that even in twilight one could see the soft haze of the Milky Way. It must be a breathtaking, perpetual evening, the kind of quiet, late dusk on Earth when the first stars appear, stretched out forever. Now our ship moves again, carrying us up and away from Proxima Centauri b. We take one last look at this world divided. On the day side, a ruddy orb with a fixed red sun. On the night side, an obsidian jewel flecked with faint starlight. The contrast is extreme, yet beautiful. A cosmic yin and yang of light and dark, In the shadowed hemisphere, we notice a gentle green glow near the pole, an aurora shimmering one last time, a farewell of sorts from this alien sky. We slip away from orbit, leaving Proxima b in its eternal chiaroscuro, that half-lit portrait of quiet extremes. As we recede, the red star Proxima itself shrinks to a ruby point among many in the blackness. The planet becomes a tiny half-disk, then vanishes into the star's glare. Soon, Proxima Centauri is just another star behind us. We carry on into the endless night between star systems, the silence of the void filling our ears once more. Carried on invisible currents of gravity and imagination, we venture outward. Ahead, other stars beckon with their subtle lights. Our next destination lies farther afield, a place where a multitude of sister planets circle a dim, feeble sun in a tightly choreographed dance. We set our course for a remarkable system of 7 worlds, a miniature solar system tucked in the darkness like a cluster of glowing embers around a campfire. The journey is gentle and swift as thought in this endless night. The black between stars gradually thins as a faint glimmer grows ahead. We have arrived at the realm of TRAPPIST-1, an ultra-cool dwarf star, even smaller and cooler than Proxima, shining with a meager but steady orange-red glow. It is an ancient star, older than our sun by far, glowing faintly as a dying ember might, yet it hosts a rich family of planets close around it. As we glide into the TRAPPIST-1 system, it feels as though we've entered a cosmic clockwork in miniature. Everything here is drawn in close to the weak warmth of the star, the planets huddled near their tiny sun. TRAPPIST-1's light is dimmer than Proxima's and far dimmer than our sun's. Yet because its planets orbit so tightly, some of them still receive enough energy that water could pool in liquid form. Up to 7 siblings circle this dim star, each locked in synchronous rotation just like Proxima b, each showing one face eternally to their sun. We approach one such world now, TRAPPIST-1e, one of the middle planets, only slightly smaller than Earth. It may be a rocky world with an atmosphere, perhaps even hospitable to life. In our minds it stands as a distant cousin to Earth, a tiny oasis in a far, cold system. We gently descend toward TRAPPIST-1e, letting the faint light of its star guide us. As we dip into the thin atmosphere, the scene below becomes clear. A world balancing between warmth and cold, between water and ice. TRAPPIST-1e, too, keeps one face always turned to its feeble sun, and as on Proxima b, this creates a day side locked in perpetual light, and a night side in endless darkness. On the day side of TRAPPIST-1e stretches a vast ocean, glittering under the dim coppery glow of the star. We find ourselves above an endless expanse of dark water. The star's rays are so faint that at first we almost think it dusk. But this is high noon on TRAPPIST-1e, an everlasting afternoon. The ocean's surface is a deep, moody colour. Where the light strikes directly, it might appear a dark teal or wine-coloured, tinted by the red-orange hue of the sky. Farther out, where the sun's rays slant and weaken, it shades into inky blue-black. The sky above is a muted peach near the sun, fading into purple-grey toward the edges. It never reaches a bright daytime blue like Earth's. There is not enough starlight for that. Instead, The firmament here is an eternal sunset, a dome painted with soft oranges and quiet purples. We see that much of the dayside is this great ocean, perhaps covering half the planet or more. Near the centre of the dayside, directly under the fixed sun, the water might be warm enough, kept liquid by the constant, if gentle, heat. But as our gaze moves outward toward where day meets night, we see the water gradually solidify. An edge of ice encircles the ocean like a giant polar cap that extends far into the night side. It's as if the planet wears a half-frozen mask. The illuminated side a dark sea, the dark side a realm of ice, meeting in a broad ring of eternal twilight. We glide lower, toward that boundary of ocean and ice, into the planet's habitable twilight ring. Here, at the very edge of the endless sea, small island chains and jagged icebergs protrude from the water, marking the transition where the ocean finally freezes. We come to rest on a stony, wind-swept isle not far from the ice wall, a lonely outcrop in this half-light world. The scene around us is otherworldly, yet oddly peaceful. The ground of the island is dark rock, worn smooth by water. Patches of coarse, rust-coloured sand have collected in crevices, perhaps volcanic in origin, ground down by the waves. Shallow tidal pools reflect the dull glow of the fixed sun, their surfaces almost mirror still in the calm air. The atmosphere here is cold and thin, but sufficient to carry sound and perhaps to support life. A faint mist hangs in the air, hugging the cool ocean surface and wreathing our island. It diffuses the starlight into a soft radiance that seems to come from all directions. To the west, over the ocean, TRAPPIST-1, the star, is low in the sky, a small but brilliant apricot-coloured orb. Though much weaker than our sun, it appears larger in the sky due to our closeness, perhaps several times the apparent size of the sun from Earth. Its light paints the mist in golden and rose tones and sets the tips of gentle waves aglow. The sun's face is dappled with star spots. Were we to look safely, we might see it mottled and uneven, a tired ember trying its best to warm its children. The ocean extends westward toward the sun. In the eternal stillness, only small waves lap at the rocky shore, perhaps driven by distant winds or by the tidal pull of other nearby planets. Each wave comes in with a hushed sigh, washing over pebbles and filling tide pools, then recedes with a soft gurgle. The water is exceedingly clear. Peering down, we see dark shapes of weed or algae clinging to submerged rocks, swaying slowly. If we dip our hand, it feels cold, only just above freezing, but liquid. It's amazing to consider that in this far-off system, water finds a way to remain fluid under a tiny sun's meagre heat. Turning around to the east, inland across our little island, and toward the night side, the environment changes abruptly. Just a short distance away, the rocky ground rises into a towering wall of ice, the edge of the night. This glacier marks where the ocean has frozen solid, a towering shelf hundreds of feet high in places, stretching north and south beyond sight, curving all along the twilight ring. In the dim light, the ice is a deep cobalt blue in its shadows, while its face, catching the star's rays, glows a pale gold and pink. Every so often, a distant crack echoes across the water as the slow-motion dynamics of the ice play out. A piece carving into the sea, or internal stresses relieving themselves. Such sounds are rare and punctuate the profound silence with a resounding, slow thunder. The sky above the ice, toward the east, is deepening into night. Only a small amount of starlight from the day side reaches here. Over the top of the glacier, stars begin to sprinkle the sky, and just above that icy horizon, a brilliant light catches our eye. It's not a star at all, but another planet, one of TRAPPIST-1E's 6 siblings. Perhaps it is TRAPPIST-1D or TRAPPIST-1F, orbiting just inward or outward. It appears as a large, bright crescent hanging above the horizon. This nearby sister world is close enough to reveal a disk and some colour to our eyes. A creamy white sliver, like a tiny version of our moon, but several times larger in apparent size. It casts a faint silvery path on the dark sea ice below. How breathtaking to see another Earth-sized world so near in the sky, tangible and real. Further up in the sky, we spot yet another point of light moving slowly against the starry background. Likely a second planet, perhaps TRAPPIST-1G, shining a ruddy hue, farther away and smaller in apparent size. It is a rare privilege to stand on one habitable world and see with naked eyes at least 2 other worlds in the same system. The sky of TRAPPIST-1E must be a constantly shifting panorama of its siblings, sometimes visible as crescents, sometimes vanishing when hidden by the glare of their star. The presence of these nearby planets has effects here too. Their gravity gently tugs at TRAPPIST-1E in rhythmic intervals. The ocean at our feet likely experiences frequent but small tides, not just from its sun, but from the passing of these planetary sisters. Perhaps every few days, the water level creeps up or down slightly, or the ice shelf groans as gravitational forces flex the planet. It's a subtle, slow heartbeat of the system, a reminder that this is not a lone world, but part of an interconnected family. The air on TRAPPIST-1E's twilight coast is calm but cold. A light breeze occasionally flows outward from the day side, bringing the scent of the sea, a mineral tang mixed with something alien, perhaps the odour of exotic biochemistry from microorganisms in the water. If life exists here, it might concentrate where water and rock meet, in these twilight shallows. We take a moment to listen carefully for any signs. Beyond the gentle waves and distant ice cracks, we discern no obvious sounds of animals. If creatures move in that ocean, they do so quietly, or at depths beyond our hearing. But one can imagine life could indeed be present. Maybe large, slow-moving filter feeders drifting in the dim shallows, or mats of algae spreading on rocks, or tiny bioluminescent plankton that light up when the waters are stirred by the tide. We decide to leave our perch and float upward a bit to gain a broader view. From a higher vantage, TRAPPIST-1E's dayside vista opens up. The twilight ring we occupied is narrow relative to the whole planet. Further west, the ice recedes and the ocean dominates. Near the centre of the face that looks toward the star, perhaps there are islands or even a small continent. Early data hint this world might not be entirely ocean. Maybe we see a faint outline of land as a dark smudge in the ocean expanse, covered perhaps in cloud. It could be a volcanic island or a small archipelago. If there is land under the fixed sun, it might host its own unique environment. A place of perpetual day, a bit warmer, perhaps arid, or with shallow evaporative seas. But from here, details are lost in the distance and haze. Instead, our gaze is drawn upward to the heavens. The star, TRAPPIST-1 glows unwaveringly. Being so dim, the concept of daylight here is very relative. It's forever twilight, even at noon. Around that star, like fireflies, 2 more of the system's planets become visible, completing a remarkable spectacle. At this moment, perhaps 4 of the 7 TRAPPIST worlds can be seen at once in the sky. One, a bright crescent, setting toward the west, maybe TRAPPIST-1d. Another, a steady, star-like dot, higher up, maybe TRAPPIST-1b or c. And the one we saw at the horizon, TRAPPIST-1f, now rising further into the dark. Such a sky would mesmerize any stargazer. These neighboring planets would spark curiosity and perhaps a sense of kinship. Sparkling lights that are actually other terrains, other oceans, other potential biospheres, just a few million kilometers away. Our time in this serene half-light is soothing. Though far colder than any place on Earth that sustains life, here it feels natural and calm. The environment has likely remained stable for eons. The star is steady on human timescales, and the tidally locked climate changes little from day to night side. Perhaps on geological timescales, the ice advances or retreats slightly, or the ocean levels change, but the daily weather is predictable. No sunrise, no sunset, just an endless slow-motion balancing of water, air, and temperature. Eventually, we know we must move on. We drift back toward our vessel, which hovers above the island. The gentle waves continue their lullaby below. On the horizon, the bright crescent of a sister planet has just vanished behind the ice cliffs, setting in an eternal eclipse. We carry with us samples of memory, the salty tang of the air, the color of the alien sunset, the sight of multiple worlds hanging in one sky. Lifting off higher, we leave behind the rocky isle, the ice wall, and the twilight sea. Below, TRAPPIST-1e's unique pattern becomes fully visible. A dark central sea, encircled by a glinting ring of ice, like a giant eye gazing into space. The day side is a dim disk, illuminated by a tiny sun. The night side is hidden in darkness, except for a faint bluish glow along the rim of ice, perhaps reflecting starlight. The other planets of the system now appear as moving points below us, each in its tight orbit around the diminutive star. We can appreciate the entire cosmic choreography. 7 worlds in resonance, orbiting in harmony around their faint sun, a miniature solar system shrouded in eternal twilight and night. Our craft gently accelerates, and we depart this remarkable system. The coppery glow of TRAPPIST-1 grows smaller behind us, its 7 sparks of planets now indistinguishable to the naked eye. Soon, it is just another orange star in the background of space. We let the silence of the interstellar gulf enfold us once more. In this silence, we reflect on the gentle wonder we felt on TRAPPIST-1e, the copper skies, frozen nights, and silent companionship of sister planets. Another memory, another whisper in the infinite library of the cosmos. We set our sights toward a brighter pinprick of light ahead. We have drifted through realms of diminutive faint stars. Now we are drawn toward a more robust beacon, a golden sun, not unlike our own. Out here in the darkness, it shines like a lighthouse in the distance, brilliant and steady. As we approach, its radiance grows from a dot to a shining orb. After the dim red twilight of the dwarf stars, this golden star's light feels intense and strong. It is many times more luminous than Proxima or TRAPPIST-1. This is a star that could warm worlds at distances we find comfortable. And indeed, a bizarre world orbits extremely close to this sun, almost skimming its fiery surface. Our next destination is a place of searing heat and perpetual fire. The planet 55 Cancri E, a super-Earth that races around its star in mere hours, locked again with one face eternally in day. As we approach the scorched planet 55 Cancri E, even from space, it astonishes us. The hemisphere facing its star is aglow like a live coal. We witness a sight like no other. The day side of this world is so hot that it shimmers and gleams with its own thermal glow, a dull red-orange radiance across half the planet. We see sprawling areas of brightness that could be gigantic lava fields or molten seas, interspersed with slightly cooler, darker patches of solidified crust. It's as if we are looking at a world caught in the act of melting. We carefully position ourselves above the night side of 55 Cancri E to observe safely out of the direct blaze of the star. The star itself, a yellow-white sun somewhat larger and hotter than our own, looms tremendously large from the perspective of the planet, many times bigger in the sky than our sun, as seen from Earth. It hangs just beyond the horizon, from where we now hover, its light still flooding the day side, but leaving our side in deep shadow. The horizon in front of us, which is the dividing line between day and night on this planet, glows a hellish orange. We have essentially arrived at an eternal sunset zone, but one far more fierce than any on Earth. This is the ring of fire, where molten rock from the day side flows into darkness. We set down on a stable area just within the night side, on what appears to be a solidified lava plain. The ground here is black and glassy, like volcanic glass, fractured by countless cracks. Beneath our feet, the surface is still warm, not glowing, but as hot as coals that have recently cooled. Here and there, we see the dull red gleam of lava coursing in rivers that wind into the darkness, gradually solidifying as they lose the star's searing heat. In the distance toward the day side, there are fountains of light, likely volcanic eruptions at the terminator line, spurting magma high into the low-gravity environment, creating brief, glowing arcs before the droplets cool and fall. The air, if one can call it that, is thin and laden with metal vapours and rock fumes. We detect the sharp scent of burnt minerals and sulphur. It's not breathable or pleasant. This is more akin to the exhalation of a furnace. Any atmosphere here is probably transient, created from the gases of boiling rock and then partially blown away by the intense stellar wind from its sun. The heat even on the night side is formidable. We can feel it radiating from the ground and from the day's glow on the horizon. Without our protection, we'd be quickly broiled by thermal radiation alone. We carefully look around. Behind us, deeper into the night side, darkness is nearly complete. The ground slopes gently downward, covered in what looks like obsidian shards and gravel from countless volcanic explosions. There may be older craters and structures, but many would have been resurfaced by the continual volcanic activity. The only illumination in that direction comes from the dim red glow that the ground itself emits, and from an unexpected source above, the sky. Even on the night side, the sky is not entirely black. Two phenomena lend a bit of light. First, the near side of the planet's own star can be seen indirectly. A weird twilight arches high above, a bent, refracted glimmer of the star's light passing through the planet's thin atmosphere. It creates a faint arc of yellowish light high in the sky, like a phantom sunrise that never arrives. Second, the molten day side casts a kind of glow onto the night side clouds. If there are any clouds of silicates or metal vapor high up, they might catch the ruddy light from below and reflect it faintly. The result is that the night side sky has a faint orange-brown luminescence, just enough to outline the jagged horizon and any tall structures or mountains. To the east, toward the hidden star, the horizon is a vivid ribbon of brilliance. We can't see the star directly, but we see its effects. The sky at the horizon is on fire. It flickers and pulses, as if sunset itself had become alive. This is because the atmosphere, thin as it is superheated at the terminator. We likely are witnessing the glow of a supersonic shockwave where day and night meet. The atmosphere rushing from the day side, heated to incandescence as it spills into night in a continuous hurricane of fire. As it cools, it may rain droplets of molten rock or condensed metal out of the air onto the ground. It's a rain no mortal would want to feel, pebbles of glass and iron descending silently, adding fresh layers to the glassy ground. Suddenly, a great bloom of light erupts on the horizon. A volcano not far from our position has erupted, throwing up a plume of glowing magma. We see it as a fountain of orange that quickly lofts and then begins to fall back. Moments later, the ground beneath us vibrates faintly as the seismic waves arrive. Even though the environment is violent, the lack of a thick atmosphere and the distances involved make everything appear strangely calm and silent from where we stand. We are observers in a silent fireworks display. The fountain of lava subsides, leaving a collapsing cloud of red sparks, where the magma droplets are cooling and raining down. Above us, directly overhead on the night side, the cosmos stands in stark relief. The starry sky here would be spectacular if one could look away from the horizon's glow. The Milky Way spills across the sky, though slightly washed by the lingering orange air glow. At least here, far from city lights and under a nearly airless sky, the universe reveals itself. Perhaps one of those distant stars is the original sun of 55 Cancri E, which has now become this blackened cinder of a world. In fact, 55 Cancri is a system with multiple planets, some farther out, including a gas giant. If conditions are right, we might see a bright star in the night sky that isn't a star at all, but one of those outer planets reflecting the golden sunlight. It might shine steadily without twinkling, a tiny beacon reminding us that not all worlds in this system are as tortured as this one. We explore cautiously along the borderline of night and day. Each step crunches on a crust of cinders and cooled droplets. It's like walking on the slag of a foundry. In some spots, the crust is thin, and a boot might break through to reveal glowing embers beneath. We stay on high ground, where the rock seems solid. Up ahead, a flow of lava has cooled into a field of hexagonal basalt columns, like the giant's causeway of Earth, but faintly glowing at the seams. They radiate heat when we approach, each column still slowly cooling from liquid rock into solid, a process that perhaps happened just hours or days ago. Curiosity pulls us a little toward the light. We climb a rise that skirts closer to the day side. Immediately, the temperature soars. We can feel searing waves emanating from over the ridge. We peek, and there it is. A direct sight of the day side from a relatively safe vantage, just within the night. A monstrous vista greets us. It is as if an ocean of lava lies just beyond this ridge, extending to the horizon where the star blazes. Parts of the terrain are indeed lakes or seas of molten rock, glowing yellow-white at the center where the heat is greatest. In other areas, we see mountains or plateaus glowing dull red, perhaps solid land that pokes above the melt, ringed by rivers of lava. The star itself dominates the sky above that horizon, a huge, white-yellow disk taking up a good chunk of sky, fringed with fiery prominences. It is perpetually noon on that side, and the land directly under the star might be as hot as 2400 degrees C, hot enough to vaporize metals. We quickly retreat from the ridge. Even through our shielding, that glimpse was overwhelming in brightness and intensity. Back in the relative safety of the darkness, it feels like stepping out of an oven into a cool night. Except this cool night is still hundreds of degrees. We marvel at how nature can create a planet so extreme, and yet so regularly patterned in its extremes. It is locked in place, one side always under the hammer of stellar fury, the other in darkness receiving the glowing runoff. One might wonder if anything could ever live here. On the surface, it seems impossible, and probably is for complex life. But maybe, just maybe, deep below, far from the scorching surface, there could be pockets where the heat isn't so deadly, near the cooler night side, or far underground where temperatures are stable. Perhaps some hardy microscopic life, if seeded here, could survive by chemosynthesis, feeding on the rich chemistry of this world's rocks and magma, akin to bacteria in Earth's deep crust or hydrothermal vents. If so, they would be oblivious to the drama above, living out slow lives in dark pores of rock, while overhead the planet constantly remolds itself. It's a faint hope, in an otherwise hellish environment, life in spite of everything. After absorbing as much as we can of this dramatic world, we prepare to depart. We lift off from our landing spot, engines glowing a brighter orange than the cooling lava below. As we ascend, the view expands. Below us, the night side is a patchwork of black and dark red, with winding glowing threads where lava rivers flow. The day-night line is a jagged belt of fire encircling the planet. Beyond it, the day side is an eye-searing semicircle of incandescence. Against the darkness of space, the planet looks like a half-closed eye, one half lit by the flames of creation, the other half a charred lid. The terminator around the limb glows like a ring of molten gold. We pass into space and quickly adjust our trajectory to avoid the intense radiation from the star. Once at a safe distance, we look back at 55 Cancri E one last time. From out here, it appears as a tiny crescent, astonishingly bright on the sunward edge, where molten surfaces reflect the light and almost invisible on the night edge, except for a faint red outline. It rotates, or rather orbits, so quickly that even during our short visit, if we had watched from space, we might have seen subtle changes in the glow patterns as fresh lava flows emerged. Now it is time to leave this furnace behind. We gradually increase our distance from the raging star, whose glare diminishes from a giant white disk to a smaller, more tolerable sun as we move outward. 55. Cancri E becomes just a glittering ember near its star, and then vanishes in the radiant light. The golden star itself, however, we can still see for some time as a bright beacon. We turn our craft away and plunge once more into the quiet and cold between the stars. The memory of searing heat and glowing horizons lingers in our minds, like the after-image of a bright light. To soothe our senses, we set our course for an environment that promises calm and gentleness, a stark contrast to the world of fire. Ahead of us lies a double star system, a place where two suns dance in the sky of a peaceful desert planet. We leave behind the singular brilliance of this star and venture toward the soft, extended light of twin suns. Drifting onward through the starry void, we soon spy not one but two stars ahead, locked in a slow orbital embrace. This is a binary star system. The two suns, one larger and one smaller, orbit a common center, and around them a planet circles, experiencing the light of both. Our next destination is this planet of the double sunset, a world of dunes and tranquility under a sky with two suns. We approach and descend into the atmosphere of the twin sun planet. At once, the vastness of a desert unfolds beneath us, a sweeping expanse of dunes shifting in gentle curves, extending as far as the eye can see. The sand is a rich melange of colours, golden in the direct light, with hints of red and copper where the lower sun casts its hue. Sparse, dark rocks protrude here and there, perhaps the remnants of ancient mountains, weathered down over millennia. It is late afternoon local time, and both suns are visible in the western sky, preparing to set. The larger sun, a warm yellow orb, is lower toward the horizon, while the smaller companion, a ruddy orange star, is slightly higher and off to the side. Their combined light bathes the desert in an ethereal, double-shadowed glow. We land softly on the crest of a high dune to observe this extraordinary evening. The air here is warm, but not harsh, perhaps akin to a desert evening on Earth, still retaining the heat of the day, but starting to cool. A delicate breeze blows, picking up fine grains of sand that tickle across the surface in dancing patterns. Each grain makes a tiny sound as it moves. Collectively, it's a faint hiss, the song of shifting sands that only an empty desert knows. The sky overhead is a pale blue fading to turquoise, but near the suns it's awash in colour. The larger sun has painted the sky in shades of orange and pink, while the smaller contributes a subtle salmon and violet tint. The clouds, sparse and high, are like strokes of a brush in rose and gold, each cloud catching the light of both stars in different gradients. We look down at the sand beneath our feet. It's fine and soft, with a slight reddish tint, perhaps from iron oxides. As the wind blows, the sand forms ripples, small dunelets on the larger dune, a fractal of wind's artwork. And in each ripple's shadow, we notice something curious, a faint doubling. Indeed, like every object here, even the grains of sand cast two shadows. We hold out our hand and see it clearly. Two overlapping shadows on the dune surface, one sharper and one fainter, one cast by each sun. As the two suns move in the sky, these shadows will shift relative to each other. It must be a familiar dance of light for any native creature of this world. We scan the horizon. Far to the north, we see a hint of stony mesas or buttes rising, perhaps an eroded plateau, its cliffs shimmering in the jewel light. To the west, where the suns approach the horizon, the desert seems to go on forever until it meets the sky in a gentle, undulating line. There might be an oasis somewhere beyond our sight, or a dry riverbed carved from an ancient time when this world was wetter. But here at our vantage, it's pure, unbroken desert wilderness. Despite the aridity, there are signs of resilience. Just a few meters from us, stands a cluster of hardy plants, low, spiny shrubs clinging in the lee of a rock where a bit of moisture and shade might collect. They have broad, waxy leaves tinted blue-grey, likely to reflect the intense daylight of two suns and conserve water. Perhaps they've evolved to photosynthesize with light from both stars, or maybe they use the combined lengthy daylight to store as much energy as possible. Their presence brings comfort. Life finds a way, even in this dry expanse. The larger sun now nears the horizon, growing redder and slightly dimmer as it filters through more atmosphere. The smaller sun is not far behind. We are about to witness something few could imagine: a double sunset. The quiet is all around us. Even the wind has lulled, as if nature itself is pausing to watch. The moment the first sun's lower edge kisses the horizon, the sky's colours amplify. A brilliant ray of sunlight sweeps across the desert from that contact point, illuminating a path of dunes with a final burst of gold. The other sun is still fully above the horizon, casting its light, so the world doesn't suddenly darken as it would on Earth at sundown. Instead, the quality of light changes subtly, becoming more reddish overall as the second sun's influence grows relative to the first. We sit down on the sand, allowing ourselves to sink slightly into its warmth. Facing west, we watch the larger sun, half submerged now beyond distant dunes. It looks twice its normal size, distorted into an oval by atmospheric refraction. Meanwhile, the smaller, redder sun is a hand's breadth above it, glowing steadily. The sky is a symphony of pastels, fiery orange near the horizon from the setting sun, merging into pink and mauve higher up, courtesy of the still shining red sun, and then into deepening indigo above. As the first sun finally slips completely below the horizon, a brief hush seems to fall. On Earth, this would be twilight, but here twilight is a complex, layered affair. The smaller red sun still illuminates the sky, preventing immediate darkness. Now we have a situation akin to an Earth-like sunset, but under a dimmer sun. The landscape is bathed in a soft crimson light. The shadows from the larger sun have vanished, but those from the red sun remain, long and gentle. The temperature begins to drop. We can feel the day's heat starting to radiate away into space, now no longer bolstered by the primary sun's rays. The sand that was hot underfoot is quickly becoming comfortable, then cool. If we turn around to look east, we find the sky there already a deep twilight blue, sprinkled with the first few stars. It's an odd sensation. Behind us, night has almost arrived, while in front of us, it's still sunset. This interlude is fairly short-lived though, for the remaining sun is approaching the horizon as well. We direct our attention back to the west. The little red sun is now descending, creating a second sunset for this day. Its hue grows deeper, from orange-red to a rich ember. The coloration it casts is otherworldly. The entire desert takes on a coppery tone, as if the sand itself is glowing faintly. Those shrubs and rocks we saw are now just silhouettes against the bright sky. One by one, the stars overhead gain confidence and start to shine. The brightest star might be the evening star of this planet, perhaps a nearby planet in the system, or a particularly luminous star in the galaxy. In the absence of a moon, we haven't noticed one yet. Perhaps there is a small one we haven't seen. The stars will hold full reign soon. Finally, with little fanfare, the top of the red sun dips below the horizon, leaving behind an almost plum-coloured afterglow. For the first time, True night begins to settle across the entire desert. Yet, even now, the sky is not completely dark. A vestige of light lingers where the two suns set, a double twilight that softly illuminates the west, long after both stars are gone. It will take some time for their light to fully fade from the high atmosphere. We breathe in the cooling air. It carries a hint of spice and dust. Perhaps during the heat of day, certain minerals or plant resins vaporize slightly, and now in the cool they condense, releasing faint aromas. Or possibly there's moisture aloft from a distant sea or lake, creating a subtle petrichor as it meets cooling sand. The breeze that had paused picks up again, now coming from the east as the desert surface cools rapidly under radiation to space. It's a bit cooler, but still gentle, a relief after the day's heat. Night creatures, if any, begin to stir. We hear a distant chirr, maybe an insect or a small lizard-like being emerging to hunt in the pleasantly cooler darkness. From another direction, a low hooting call echoes between dunes. It could be a bird analogue, or something like a fennec fox calling out to a mate under the twin afterglow. Life here likely operates in the margins. Morning and evening would be extended thanks to the dual suns, giving a longer window of cooler time to be active. Perhaps creatures here evolved to take advantage of the overlapping schedules. Maybe they come out after the primary sun sets, but before the second does, capitalizing on the red sun's dimmer light to seek food while still being able to see. Above, the sky continues to darken. The band of the Milky Way reveals itself, shimmering across the dome of night. Without a bright moon or single sun, and with the planet likely having a rotation period ensuring a decent length night, the starfield is rich and steady. Some of those stars have subtle colour, a blue one here, a red one there, but none compare to the two brilliant jewels that grace this world's sky by day. If a traveller from Earth were here, they might look for recognizable constellations and find them warped or shifted due to being light years from home. But new constellations are born from this vantage point, perhaps inspiring local mythologies of two-hearted gods or twin spirits dancing among the stars. Over the eastern horizon, now the darkest part of the sky, a faint glow appears. For a moment, we might think a city lies in that direction, but it is likely the planet's own zodiacal light, sunlight scattering off dust in the orbital plane, or perhaps even an aurora. The magnetic field of this planet could be active, and with two suns providing stellar winds, auroras might be more common or strangely doubled. As our eyes adjust, we see a pale green-blue wisp low in the north, likely an aurora oval peeking down. It flickers gently, then fades, leaving the stars to shine. We remain seated on the dune for a long while, enjoying the coolness and the grandeur of this double night. The sand, still slightly warm beneath, now also radiates a subtle chill on its surface, a contrast that our senses note. It reminds us of sitting by a campfire in a cold desert, one side warm, the other side cool. Here the warmth comes from below, and the cool from the air above. It's time to continue our journey. We stand and brush off fine sand from our clothes. It cascades off in a soft whisper. The twin shadows that accompanied us have become one faint shadow under the light of the stars, and maybe a subtle glow of the galaxy's light. Far in the west, the horizon still holds a memory of the suns, a subtle double light that lingers like a distant promise that they will return, and they will. Dawn here will be as gentle and drawn out as dusk, with first a red sunrise and then a second, brighter sun following. two dawns, to rouse life from slumber. We ascend from the dune, our craft rising silently into the night sky. Below, the patterns of dunes become apparent. Long chains, sculpted by prevailing winds, shining softly where starlight catches their crests. We can see the dark spots that are rock outcrops or clusters of vegetation, and perhaps the silvery trace of an ancient dried riverbed snaking between dune fields, reflecting a bit more starlight. It's a serene, inviting landscape, despite its harshness. One could wander here under the double stars and find beauty at every turn. As we climb higher, the two suns reappear. Not directly, but we can see the area of the sky where they set still aglow, and soon, on the opposite side of the planet, their counterparts of dawn will start to brighten. But we won't stay for sunrise here. We have more to see elsewhere. From orbit, this binary star planet looks like a pearl set against the black of space, lit on one side by the faintest blush of twin twilight, and on the night side by the silver of its sands under starlight. The two suns themselves are now out of view, but their influence is everywhere. The slightly elongated orbit of the planet, the subtle variations in day length and temperature cycles, the likely lack of a single dominating moon, as the gravitational dance might make stable moons a challenge. It occurs to us, perhaps the binary pair has other planets too, orbiting further out or in between. If so, those planets might experience even stranger light patterns, or even see this desert world as a bright, double star object in their sky. With a soft sigh of our vessel's engines, we bid farewell to the world of twin sunsets. It was gentle and contemplative, exactly the respite we needed. Now we turn our attention to a new target shimmering ahead. Our next journey will take us to a world swathed in thick clouds and heavy air, a massive super-Earth where rainforests or endless swamps might dominate. We leave the arid stillness of the desert and the vanishing double glows of its suns, and glide onward toward a moist, golden world lurking in the distance. From the barren dryness of the Twin Sun Desert, we traverse onward to a world awash in moisture and suffused with heavy air. In the velvet darkness between stars, a new sun draws us in, an old, golden star, somewhat cooler and redder than our sun. Around this venerable star orbits a super-Earth, a planet more massive than our own, with a dense atmosphere and a rich, humid environment. As we drop out of hyperspace and into this planet's vicinity, gentle light greets us. This star's output is steady and genial, bathing its planets in a warm glow. We slide into the thick atmosphere of the super-Earth, prepared for an embrace far different from the desert's dry kiss. Immediately we feel the difference. The air is dense, almost syrupy, and gravity holds us with a firm hand, stronger than Earth's, but not crushing. We descend through layered clouds coloured in soft gold and pale orange by the late afternoon sun of this world. The experience is like drifting down through honeyed sunlight. Soon the clouds part enough to reveal the ground below, a landscape of rolling hills blanketed in lush, misty forest, and wide, marshy lakes gleaming dully in the filtered light. It's a scene that exudes tranquility and ancient life. We set down on a gentle hill covered in spongy moss and ferns. The ground welcomes our footsteps with a soft give, springing back slowly. Every step is slightly laborious due to the high gravity, but the thick atmosphere helps cushion our movements. The weight of the air itself is palpable. It presses on our skin like a warm, moist blanket. Breathing, were we to try without assistance, would be like breathing in a sauna, dense and full-bodied. The scent that greets us is rich and loamy, decaying leaves, fertile mud, and the faint sweetness of flowering plants. It's the smell of life, flourishing in every nook, amplified by the humidity and pressure. The sky overhead is a blanket of high clouds, allowing diffuse sunlight through but hiding the sun itself. It might be mid-afternoon, but the light has the quality of perpetual late day, a golden, indirect glow that casts almost no sharp shadows. Indeed, looking around, we see that shadows are faint and blurred, as if the whole sky itself is a light source. This world likely rarely sees a clear sky. Its atmosphere is thick with moisture and perhaps aerosols. The result is an eternal haze that makes the daylight soft and ruddy, like living in an endless sunset. We are atop a hill, and below us stretches a broad valley filled with a patchwork of shallow lakes and slow rivers. Giant trees with buttressed roots line the water bodies. Their canopies are broad and flat, perhaps an adaptation to gather as much sunlight as possible in this hazy world. The leaves are dark, almost black-green, likely loaded with pigments to capture the dim light. They shimmer slightly, perhaps coated with moisture. Ferns and mosses carpet everything at ground level, thriving in the dim light, where on earth they might struggle. Drizzle begins to fall, large, heavy raindrops that plop onto leaves and moss with a rhythmic patter. Rain on this planet falls slower than on Earth. The thick air and higher gravity cause a terminal velocity that is surprisingly gentle, so each drop, though large, doesn't strike hard. We walk under the cover of some trees as the rain strengthens. Instead of a cacophony of drumming, the sound is a muffled, constant hush, like thousands of tiny footfalls on a soft surface. The heavy atmosphere and lush vegetation dampen the sound quickly. In the valley, a fog is rising from the lakes, stirred by the rain's disturbance. Wisps of white steam curl upward, only to be trapped under a higher layer of cool air, forming a horizontal sheet of mist that hovers ghost-like above the water. Through this ground fog, the dark forms of large creatures can be seen moving slowly. Perhaps great herbivores, akin to hippos or swamp dinosaurs, wallow in the warm shallows, half submerged and languid. We hear a distant call, a low bellow that vibrates through the ground. In this dense air, sounds travel differently. High-pitched sounds are absorbed quickly, but deep sounds carry far. It gives the environment a dreamy auditory backdrop. We catch the deep croaks and hums of creatures, but any bird-like chirp or insect buzz is muted unless very close. And indeed, close by, beneath a broad leaf, we see a small amphibian-like animal chirping. It looks like a cross between a frog and a newt, with multiple frond-like gills fluttering on its neck. It emits a tiny peep, but in the dense air, it comes out as a mellow whistle. The creature seems unbothered by us. Perhaps the concept of large, dangerous animals is different here, or we blend into the environment well. It hops a few inches and snaps at something we didn't even see. A translucent flying insect, maybe, that only becomes apparent when caught. The rain abates, leaving everything even wetter than before, if that is possible in this saturated world. Droplets hang off every leaf and frond, not evaporating. They'll likely remain until shaken off or absorbed. Immediately after the shower, the air somehow feels even fresher, laden with the scent of petrichor, the smell of rain on dry earth. Though here it's more like rain on ever-wet earth, and a hint of ozone. We notice on the far side of the valley a waterfall has sprung to life, likely fed by rain on the highlands. It cascades down black rocks, not as a roaring torrent. Nothing seems to roar in this thick air, but as a silky ribbon, almost in slow motion. The sound comes to us as a pleasant, steady hum. As the clouds overhead part slightly, a sunbeam actually breaks through, a rare direct spotlight from the hidden sun. It illuminates a section of the valley with brilliant golden light. In that moment, the true colours of this world come alive. The canopy glows emerald and amber. The water in the lake sparkles, and we see it stained tea-brown. Tannins from vegetation, perhaps. The mist takes on a rainbow tint at its edges. And then, as quickly as it came, the gap in the clouds shifts and the sunlight becomes diffuse again, the world returning to its softer palette. Under such nurturing conditions, life here might be slow but bountiful. The high gravity would encourage stocky, powerful forms, and indeed, as we roam a bit, we see massive, snail-like creatures inching up tree trunks, each the size of a small dog, with shells encrusted in what looks like moss and fungus, camouflaged as part of the tree. High above, something glides between branches. Not a bird as such, maybe a membrane-winged lizard, taking advantage of the dense air to soar with little effort. Their calls are distant clicks that we barely discern. One peculiarity stands out, the length of the day. Because this planet rotates more slowly, perhaps due to its size or tidal locking tendencies, the daylight seems drawn out. It might be that a single rotation here takes longer than on Earth. The perpetual cloud cover also makes the concept of time of day less sharp. We realize we've been here for quite a while, yet the ambient light has barely changed. It might slowly dim into a long golden hour before true night falls, if it does at all. Some super-Earths might be tidally locked, but let's assume this one rotates enough to have a day-night cycle, albeit a long one. This lack of urgency permeates life here. Nothing is in a hurry. The plants grow slowly but huge. The animals move with calm deliberation. The weather shifts gradually. We wander down toward the valley, drawn by the sight of one of those shallow lakes. The ground squelches under our feet as we step off firmer high ground onto marshy soil. At first, our foot sinks unexpectedly deep, up to the ankle in mossy mud. The gravity making our weight more, and the sogginess of the ground means we must step carefully on tussocks and exposed roots. Eventually we find a sort of natural path of firmer ground, leading to the water's edge. The lake is perhaps knee-deep across much of its expanse, with deeper channels here and there. Under the water is a thick layer of dark peat and decaying plant matter. Bubbles of methane or other gases occasionally burp to the surface, leaving concentric ripples that expand slowly and lazily due to the high gravity and drag of the dense water. Water might be slightly denser here with dissolved compounds, and the gravity flattens waves quickly. At the lake's edge, we kneel and dip a hand in. The water is lukewarm, not cold like one might expect. This world likely has a strong greenhouse effect due to its dense CO2 and water vapor atmosphere, keeping even night times and polar regions relatively warm. The lake teems with life. Little fish-like creatures with rudimentary lungs gulp at the surface. Insectoid things skate on the water tension. Those must be specially adapted, as the gravity would normally make that impossible. Perhaps the surface tension is boosted by organic films on the water. The mud is alive too, with burrowing worms and crustaceans filtering the rich organic soup. Across the water, those large herbivores we glimpsed make their way closer. They resemble hippos or tapirs in body plan, with 6 sturdy legs splayed to distribute their weight. Their skin is thick and pebbled, with a pattern of algae growing on their backs, a symbiosis maybe. They munch on the aquatic plants, occasionally snorting. One submerges its entire head to uproot some tubers, then raises it, dripping, chewing contentedly. They seem peaceful, and in this heavy gravity, charging or quick movements would be taxing, so perhaps they rely on size for defense rather than speed. Before leaving, we experience one more wonder: twilight. It seems the sun is finally low, although we never saw it directly. The cloud cover has taken on a deeper shade of amber, and the light now is truly like that of an Earth sunset, but without the dramatic colours in the sky. Everything just gently darkens and reddens. Fireflies, or some bioluminescent analogue, begin to wink in the underbrush. Tiny floating orbs of green light drift above the warm lakes, possibly some kind of glowing spore or insect that rises with the evening mists. The effect is enchanting. The valley fills with these will-o'-wisps, as the calls of nocturnal creatures increase slightly in volume. There is still no true darkness. It's more like a very overcast dusk, thanks to the scattering of light in the atmosphere, and perhaps a bit of afterglow from the star, or even light from a large moon or the galaxy. But it is dark enough that the bioluminescence stands out. We decide to take our leave while we can still navigate easily. We make our way back up to the hilltop where we landed, guided by memory and a faint glow we left on our craft. The climb is a good workout. Our muscles definitely feel the extra pull of gravity now after hours of moving around. It gives us appreciation for how strong and stout native life must be. Back at the crest, we turn for a last panorama of this heavy paradise. The valley below is now shrouded in a soft darkness, with a million pinpoints of light from the living lanterns of insects or plants. The air is alive with a low thrumming, perhaps a chorus of giant amphibians singing in the distant swamps, their bass voices harmonizing through the dense air. There is a rhythmic quality to it, like a slow heartbeat of the night. Above, the clouds have parted just a little, revealing a portion of the sky and the stars beyond. Interestingly, we notice a bright spot among the stars with a steady glow. Likely this planet's star shining through a gap near the horizon, or possibly a nearby planet in the system. If it's the star, it means the sun has set, and we are seeing it directly for the first time. It's a deep orange star, large and swollen, consistent with an older star. It twinkles just a bit. Then the cloud gap closes and it's gone. If it's a nearby planet, perhaps it's reflecting the sun's light from above the clouds where it's still day. Either way, it's a rare sight in this normally overcast dome. Our craft is beaded with moisture, like everything else here. As we power up, the droplets on the windshield slither off in thick rivulets. We lift off gently, careful not to startle the creatures with a lot of noise. The thick air carries sound well, so we use a stealthy, silent mode for ascent. Up through the clouds we go, once again entering the endless golden haze. It grows lighter around us before it grows darker, an effect of leaving the dark surface and catching the lingering daylight above the cloud deck. Finally, we burst through the top of the cloud layer into the upper atmosphere. Here, the sky is a rich purple, and the sun is a half-seen orb on the horizon. We can appreciate the vast scale of those clouds. They extend like a blanket as far as we can see, with only a few high mountain peaks or plateau tops piercing through as dark islands in a golden sea of vapour. Soon we are in space, looking down on the super-Earth. Its night side has a dim glow from all the atmospheric scattering, a kind of perpetual aurora and air glow combined. We see flickers of lightning in a broad band, likely massive storm complexes at the equator, illuminating the cloud cover from within with each flash. There might even be a giant hurricane swirling slowly, its form visible as a subtle spiral in the cloud tops, backlit by starlight, Carrying the memory of warm rain and gentle twilight with us, we depart this heavy world. The aging golden star that warmed it recedes behind us, a kindly beacon that slowly shrinks. Our hearts feel light, even if our bodies felt heavy there, a testament to the deeply relaxing, womb-like comfort of that environment. Ahead, a small blue shimmer catches our attention against the black. We know our next destination lies in that direction, a true ocean planet, a world of water from pole to pole. Leaving behind the thick clouds and forests, we now set our course for an endless sea under alien skies, eager to taste the salt of a faraway ocean and hear the lullaby of its waves. Guided by a beacon of cerulean light, we arrive at a world almost entirely covered in water. From space, this planet gleams a rich blue, marbled only by white cloud swirls and perhaps the dark outlines of deep ocean currents. It's an ocean planet, possibly akin to those scientists call water worlds. As we descend through its atmosphere, we can see no land breaking the surface, at least not in this hemisphere. The notion of a boundless ocean stretching everywhere is both awe-inspiring and oddly calming, like returning to a primordial cradle. The sky we emerge into is a brilliant midday blue, the clearest sky we've seen in a long while. The sun of this world is a warm yellow-white, not unlike Earth's sun, and at about the same intensity. Here is a world at just the right distance to have temperate conditions, but it ended up with far more water and far less land. Puffy white clouds speckle the sky, but large expanses remain open, letting the sun glint off the water below. The ocean is a deep indigo when seen at angle, and a bright turquoise where the sun's rays penetrate and reflect back. We level out just a few hundred meters above the waves and skim along, the sea breeze rocking our craft gently. We decide to set down directly on the water, as one would a seaplane on a calm day. Our vessel has that capability. With a light spray, we touch the surface and bob to a halt, floating. The vast ocean extends in every direction, a subtle heaving of swell after swell, long rolling waves that carry the momentum of distant winds. The nearest thing to land we can see is far on the horizon, perhaps an iceberg or a large floating raft of seaweed, or maybe just a trick of cloud shadows. For now, we're alone with the water and sky. We step out onto the top of our floating craft and then down onto the surface. We are wearing flotation and gentle anti-grav belts for safety. Not sure what creatures might lurk, but initially we simply wade in. The water is pleasantly cool, akin to Earth's oceans at mid-latitudes. It has a higher buoyancy though, suggesting it might be a bit more saline or contain different minerals. We lie back and float, looking up at the sky. The sensation is wonderful. The water cradles us, the slight undulations causing us to drift up and down. The sun is warm on our face, and a few small cloud puffs drift lazily overhead, occasionally giving us a moment of shade. There is a peaceful soundscape here, the water gently lapping against our vessel and our bodies, a distant soft roar from larger waves perhaps a kilometre away, and the soft sigh of the breeze. There are no birds crying. Perhaps there are no flying animals at all if there's no land, or if there are, they might nest on floating algae mats or on rare emergent rocks. The quiet is broken only by the rhythm of water itself, an endless, soothing conversation of wave and wind. We sit up in the water and look down through our goggles into the depths. Sunbeams pierce the ocean, illuminating a vivid blue world beneath. Just a few meters below, we see a school of translucent, ribbon-like creatures gliding by. They look like eels made of glass, shimmering with iridescent patterns along their sides. They weave effortlessly through the water, occasionally coming near the surface to nibble on something microscopic. Deeper down, maybe 20 or 30 meters, we can make out a dark, reef-like structure. It could be a kelp forest equivalent, or a chain of volcanic chimneys, or perhaps some weird coral analogue that doesn't need land. It's teeming. We see flashes of bioluminescence in the shadows, and quick darts of silver as predator fish chase prey. The water world likely has a complex ecosystem entirely in the ocean. Perhaps there are floating structures that are homes to small creatures, akin to plankton rafts or giant jellyfish that serve as platforms for others. We do notice a gelatinous blob drifting nearby on the surface. It's large, about a meter across, almost like a big transparent pillow with a fringe of cilia around it. It pulses gently, moving with the current, possibly feeding on microorganisms by filtering water. A few small fish-like animals swim in its lee, maybe nibbling parasites off it or using it as shelter. The interdependence is beautiful to witness. Everything here floats, so life has adapted to live either in open water or attached to something that does. We climb back onto our vessel to take a broader survey, and because we notice fins in the distance, larger beings are approaching, possibly curious about our presence. We wouldn't want to become an accidental meal or disrupt their behavior by being in the water directly. From our vantage point, we watch as a trio of dolphin-like creatures approach. They have sleek bodies, azure and white, with bioluminescent streaks along their sides. They arc out of the water playfully, spraying glittering droplets that catch the sun like liquid diamonds. It appears they might be intelligent, or at least socially complex. They circle our craft a couple of times, perhaps scanning us with whatever senses they have, then lose interest when we don't respond in kind. They disappear into the blue depths with a final flick of a tail and a trail of twinkling blue lights that slowly fade. The day wears on. The sun, nearly overhead, slowly tilts toward the west. We realize how clear the sky has been. Our first truly sunny day in this interstellar voyage. The effect on our mood is palpable. We feel energized, yet tranquil. A perfect balance. This world would be ideal for a restorative retreat, if one had means to float a habitation. We decide to explore the water from above before we leave. Activating a small underwater drone from our craft, we send it to dive beneath us and transmit images. The view plunges down, giving us a glimpse of life hundreds of meters below. We see what looks like a massive shoal of plankton or jellyfish, drifting in a slow circular gyre. Perhaps the currents make a deep-sea vortex where nutrients gather and life follows. Larger, whale-like filter feeders glide through it, mouths agape, taking in tons of water and expelling it through baleen-like filters. One such giant passes near the drone. It has a majestic, elongated body with multiple pairs of flippers, almost like the Leviathan from Earth's myths, serenely cruising the open ocean. On the seafloor, which on an ocean planet might be extremely deep, depending on crust thickness, but perhaps in this area it's shallower. We catch sight of thermal vents glowing, like underwater campfires. Around those vents cluster colonies of organisms. Here life that doesn't depend on sunlight thrives, turning minerals and heat into sustenance. It's reminiscent of Earth's hydrothermal vent ecosystems, with tube worms and clams, though the specifics differ. Our drone lights catch reflective eyes and shimmering cilia waving in the dark depths. We retrieve the drone and note the time. Nightfall will come in an hour or two. Keen to witness an ocean sunset, we stay on the surface as the evening arrives. Clouds on the horizon to the west have gathered, likely a sign of weather, or just the condensation of the day's humidity. They will make the sunset all the more spectacular by catching colours. The sun begins its descent and the sky transforms. The blues overhead deepen to royal blue, while near the horizon, a palette of orange, peach, and pink unfolds. The clouds ignite with colour, edges golden where they face the sun, undersides turning magenta. The water reflects these hues, so we are floating in a painting of pastels. As the sun touches the horizon, half obscured by clouds, a soft chill enters the air. Day's heat is dissipating quickly over the vast ocean, perhaps leading to nighttime storms when it cools. For now, though, the breeze is gentle. The waves seem to calm as if paying respect to the retiring sun. The horizon is a line of molten gold where the sun's last light stretches across the water right toward us. We bask in it, letting the visual splendor wash over our eyes. This is one of those moments that feels eternal, when the boundary between day and night, between water and sky, blurs in a symphony of light. Finally, the sun slips away, leaving a brilliant afterglow. The sky is still bright for a while. We see the first stars peep out in the east. The planet's 2 moons, if it has any, might become visible. We do notice one faint crescent following the sun down, maybe an inner moon, and another, larger moon rising opposite, but very dim and likely ice-covered, reflecting the sun's light faintly. The larger moon might also be a water world stabilizer, preventing extreme tilts. Or maybe not. Maybe this planet's axis is stabilized by the ocean itself. Dusk deepens. The clouds that were pink now turn to deep grey, then black silhouettes against the greenish afterglow low in the west. Overhead, the vault of night unveils itself. The Milky Way, free from any light pollution or obscuring atmosphere. The air here is clear and free of dust, because dust would settle into the ocean quickly, shines so profusely that it casts a subtle glow on the water, enough that our eyes can discern the gentle rise and fall of nearby waves. The 2 moons, now both above the horizon, one small, one larger but dim, add their touch. Twin silver paths on the water, overlapping with the residual glow of the sky. We become aware of a new light phenomenon. The ocean itself is starting to glow in places. It begins when a fish jumps near our craft, perhaps chasing prey, and when it splashes back into the water, a burst of blue luminescence spreads like a firework. Bioluminescent plankton, perhaps akin to Earth's dinoflagellates, respond to agitation by emitting light. Excited, we trail a hand in the water and swish it around. Sure enough, 1,000 tiny blue sparks swirl in the wake of our hand. It's as if we are summoning stars from the sea to mirror the ones in the sky. Soon, every small wave breaking, every ripple, every movement in the water creates ephemeral, blue-green glowing patterns. Looking down into the water, we see ghostly silhouettes of creatures outlined in light, perhaps hunting or fleeing, causing bioluminescence as they move. It is a quiet fireworks show all around us. The ocean world by day was beautiful in blues and greens. By night, it turns into an enchanted realm of silver, black, and neon blue. We remain a while longer, laying on the deck of our craft, gazing upward. It's rare to see such a clear sky. We identify familiar constellations from Earth's skies, indicating we might not be too far, galactically speaking, from home, and new patterns as well. A shooting star suddenly streaks across the sky, burning up in the atmosphere and leaving a short-lived trail. It reminds us that even here, in this seemingly endless tranquility, the cosmos has its dynamics. Perhaps a piece of comet hitting the atmosphere. Maybe comets seeded this ocean with water long ago. At length, we know it's time to leave. Part of us could stay here indefinitely, floating and exploring and dreaming under these alien stars. But our journey continues. We take one more deep breath of the moist, salty air, filling our lungs with it to carry its memory. The salt tang, the organic richness, the freshness. It will stay with us, a scent memory of this distant ocean. We lift off slowly, to not disturb the water too harshly. Nonetheless, the thrusters cause a bloom of bioluminescence in the water that spreads out like a blue halo beneath us. We rise higher, and the circle of glowing plankton expands outward and fades. Climbing into the sky, we get a final panoramic. Half the planet's face is in night now, with only starlight and a faint auroral glow at the poles, while the other half, further west, still has a dim twilight. In low orbit, we see a massive thunderstorm system on the night side, flickering with lightning like neurons firing. Perhaps tomorrow it will roll overhead where we just were, bringing torrential rain and wild winds. The life of a planet-wide ocean is intimately tied to its weather. Leaving the ocean world behind, we set our trajectory outward. As we depart, the blue planet recedes, shimmering, then becoming a small azure dot, then nothing at all but a memory of blue. Now our route takes us to a dramatically different spectacle, one not of a single world, but of a world dominated by the influence of a far larger companion. We are bound for a majestic ringed planet and its moon, a place where a solid moon has skies filled by the planet's rings, a permanent celestial display dominating the heavens. As the starlight of this system comes into view, we find ourselves approaching a gas giant comparable to Saturn, with broad, shining rings and multiple moons. Our travels carry us next to this magnificent giant. From afar, the gas giant planet is a breathtaking sight. Muted bands of cream, gold, and ochre encircle it, indicating belts of clouds and enormous storms, and its rings, countless particles of ice and rock, form a flat, shining disk around its equator. It's situated around a star that's somewhat similar to our Sun. Perhaps this is an analogue of Saturn in another solar system, or maybe a completely different giant, with its own character. Either way, one of its moons lies in the habitable zone, or has conditions suitable for exploration, which is why we're here. We aim for that moon, a medium-sized moon with a thin atmosphere, a rocky surface, and, if our instruments are correct, liquid water in some form. It might be a bit cold, perhaps like a larger Titan without the thick haze, or like a small Earth that never quite developed fully. But one thing is certain. From its surface, the view of the ringed planet must be one of the most spectacular vistas imaginable. We descend to the moon's surface on the hemisphere that permanently faces the gas giant. Many moons are tidally locked to their planets, So one side always faces the planet, just as our moon always shows us the same face. In doing so, we ensure the giant planet will be continuously visible in the sky above us after landing. We touch down in a flat plain, dotted with ice and rock, perhaps somewhere near the moon's equator. The gravity is low, much lower than Earth's, perhaps about 1/5 or so. We bounce slightly as we step out, feeling light and agile. Then we look up, and the sight nearly takes our breath away. Filling the sky, at an immense scale, is the gas giant planet. It looms far larger than any full moon ever could, dozens of degrees across. A gargantuan globe hanging above the horizon. Its rings are angled across the sky like a colossal bridge of light, stretching from one end of our vision to the other, broad and luminous. The planet's banded atmosphere is visible in detail. We can see a dark amber band, a pale yellow band, even hints of cyclonic storms as small spots. One hemisphere of the planet is sunlit, the other in darkness, as it is daytime here on the moon. The terminator line on the gas giant is visible as a curve of shadow slowly creeping or retreating, depending on relative motion. The rings on the day side gleam brilliant white and gold. On the night side, they are a dimmer outline, lit by the faint glow of distant starlight, or perhaps by the reflected light from the planet's day side. Rings can reflect the planet's shine too. There is a thin atmosphere here. We see a slight haze, and the horizon is not razor sharp. Likely it's a tenuous mixture of nitrogen and argon, maybe with a bit of methane or other gases. It's enough to scatter sunlight and create a blue tint near the horizon, but not enough to breathe or significantly impede our view. We have our suits on, but we can still hear sound. The atmosphere can carry it. The faint whisper of a cold wind blowing across the plain, and the soft crunch as we step onto ground that's a mix of regolith and ice. The terrain around us is relatively flat, with some small craters and boulders. Patches of the ground glitter, probably water ice or hydrocarbon ice, reflecting the light from above. The temperature is frigid, as expected on a moon a bit far from the star, but sunlight plus the planet's reflected light makes it surprisingly bright, almost akin to an overcast day on Earth in luminosity. The rings cast shadows, even here. Not a single continuous shadow, but a pattern. Because the rings are not a solid object, but billions of particles, the sunlight passing through them onto the moon creates a complex, somewhat diffuse band of shadow on the surface. If you look at the ground, you can see a broad, slightly darker stripe where the rings are blocking some sunlight. It's a subtle twilight band that moves as the planet moves relative to the sun. Stepping into that stripe, the daylight dims a little. Stepping out, it brightens. It's like standing under a very large, partially translucent canopy. We walk across the plain toward a small rise. Low gravity makes each step a long, bounding arc. It's easy to overdo and find oneself momentarily airborne. We get the hang of it and hop gracefully, covering tens of meters in a single bound, feeling like we could almost fly. Each landing kicks up a puff of fine, powdery dust which lingers longer than it would on Earth, swirling slowly in the thin air before settling. From the rise, our vantage improves. Now we can see more of the landscape and the sky. To the west, the sun is actually behind the gas giant at the moment, meaning the giant planet is in front of the sun from our perspective, creating an eclipse. We realize that's why part of the rings and the edge of the planet have a beautiful halo. The sun is just behind, lighting the rings from behind and refracting through the planet's upper atmosphere. A bright arc encircles the portion of the planet's silhouette, a solar corona of sorts, or a glory, making it appear as if the planet has a glowing outline. This also means we are in the giant's shadow. Effectively, it's like a deep partial eclipse here. That is why the ambient light on the moon's surface is not as intense as it could be. We are in a twilight cast by the eclipse. How fortunate. We did not plan it exactly, but the orbital dance has given us a front row seat to a cosmic event. The sun hidden behind the gas giant, the rings shining from behind, scattering light toward us in an ethereal display. During such eclipses, interesting things happen. The temperature on the moon might drop quickly, causing the air to condense a bit. Indeed, our suit's readings note a slight pressure dip. Perhaps some of the thin atmosphere is freezing out as temperature falls. We see glints on the rocks intensify. Could it be a thin frost forming in real time? Possibly moisture or other volatile compounds are crystallizing on surfaces as the sunlight is cut off. We also take a moment to look around for other moons. This gas giant likely has many. Sure enough, we see a bright star, not too far from the giant planet's edge. That's likely another moon, maybe the one outward from us. It shines steadily. If there are inner moons, they might be hidden by the planet right now, or too small to see easily. One inner moon, perhaps, is crossing behind the rings. We notice a little shadow on the rings themselves, a small oval moving across them. That could be the shadow of an inner moon cast upon the rings by the still, somewhat angled sunlight. The geometry of light and shadow in this system is complex, but mesmerizing. Now the eclipse begins to wane. The sun is emerging from behind the gas giant's disk. A blinding diamond of light appears on the planet's rim, the so-called diamond ring effect, as a burst of sunlight breaks through a valley in the planet's atmosphere, perhaps. We avert our eyes momentarily, then see the landscape brighten dramatically. Shadows sharpen. The ring's shadow band on the ground becomes more defined or shifts. The sky goes from twilight back to daylight, albeit an alien daylight with a big planet in the sky. In full day conditions, what colour is the sky? Possibly a pale blue or grey, given the thin air, or even a slight orange if there are Titan-like hydrocarbons. But since we see stars and the Milky Way at night on this moon, and the day's sky shows blackness around the planet's silhouette, the atmosphere might be extremely thin, so the sky is mostly black even at day, except near the horizon where dust and ice crystals make a faint blue glow. We look up at the planet now, fully illuminated on its facing side. It's overwhelming in grandeur. If there were mountains or tall structures here, one could see the planet, even on the horizon, as a gargantuan presence looming above. One can't help but feel humble and perhaps a bit vulnerable, living on a moon under the watch of such a giant. Did any life form here ever gaze up and form myths about their protector or oppressor in the sky? Perhaps thinking the rings were the stairway to heaven, or the embodiment of a deity's encircling arms. The gas giant does act as a protector. Its gravity likely sweeps many comets and asteroids, shielding the inner system. However, there's also a constant rain of radiation in its magnetosphere that can be harmful. We have to be mindful of that. Many gas giants have strong magnetic fields that can bathe their moons in radiation belts. Our instruments indeed show elevated readings during the eclipse, the planet's magnetotail perhaps, but this moon might have some protection via a bit of atmosphere or its own magnetic field, After taking in the spectacle for a good while, time is hard to measure when one is enraptured, but we might have spent hours just staring and wondering. We decide to sample the environment a bit. We find a small depression where some whitish material has accumulated. Could be frozen gases or water ice. Chipping a piece off, we analyze. It's mostly water ice with traces of ammonia, possibly outgassed from the interior, or deposited from ring particles, or Saturn-like Enceladus geysers. It's a little cosmic snow cone from the moon. In the distance, along the horizon, we notice a range of hills or low mountains. It might be interesting to go there, but time is limited, and we prefer to focus on the sky, which is the true draw here. We settle down on a flat rock just to exist in this place for a moment without actively exploring, to simply be. The colossal planet above, with its rings and storms, fills our field of view. It's a silent sky show now. The eclipse over, the planet moves quietly in its orbit, the rings glint, an occasional meteor, perhaps a ring particle falling into the atmosphere, streaks as a brief spark near the planet. We can even make out the relative motion. Over the hour, the rings tilt ever so slightly, or the planet's face rotates. Spots we saw earlier have moved. This gives a strong sense of the reality of it. It's a dynamic planetary system, not a static painting. The sun is now westering for us as well. This moon rotates as it orbits, likely keeping the same face to the planet, but not necessarily the same face to the sun, depending on orbital resonance. If it's like our moon, day and night still occur from the sun's perspective, even while the planet remains fixed in the sky. So the sun will set, and we'll have night here while still facing the planet. The thought of seeing the gas giant at night, lit by rings and maybe some aurora, is enticing. We decide to wait for dusk on the moon. It's not far off. The far horizon is growing purple, and the temperature is dropping. As the sun dips low, the gas giant's visage becomes even more striking, now lit from the side, giving it depth. We can see the curvature more clearly, and the rings cast a bold shadow across the planet's face, a dark band slicing through the equatorial region now that the sun is at a lower angle. It's like someone drew a black line across the planet, the shadow of the rings on the planet's cloud tops. The sky darkens to a deep blue, then black. Stars emerge. And guess what? One of the first stars to appear is actually the planet's reflection. Sunlight reflected off those icy rings casts a soft illumination even after sundown. So the planet now glows not just by its own reflected daylight, which is mostly on the far side now, but by the rings that are still catching the sun's rays and shining. It's a bit like a giant lantern in the sky. Thus, our night is not completely dark. It's a ring-lit night. The ground has a faint twilight gleam. It's akin to Earth's full moon nights, but the light is coming from that stripe across the sky. This must be magical. And indeed, as the sun fully sets, the rings shine in the night like a colossal arch of white fire. They are not as bright as day, of course, but bright enough to cast subtle shadows. If we hold up a hand, we see a faint double shadow, one from the rings, one from any other light sources. Maybe the planet itself luminesces slightly from airglow or aurora. It's like a perpetual aurora borealis, fixed in the sky. We check the northern horizon near the planet's poles. An aurora is indeed visible. The gas giant has auroral ovals, and from our angle, we can see the northern one as a curtain of greenish light rippling around the pole of the planet. Absolutely astonishing. An aurora on another world, huge and distant, but clearly visible. It brightens and fades, and occasionally flares with a touch of purple at the edges. All these sights, the rings, the aurora, the looming planet, make this moon's night sky arguably one of the most spectacular in the galaxy. We are grateful to have witnessed it in person. Eventually, feeling a mix of elation and peacefulness, we know it's time to move on. There are yet more wonders to chase, deeper mysteries to touch. With a final long look at the cosmic vista above, we return to our ship. We lift off from the quiet moon, leaving only footprints that tomorrow might be erased by frost or micrometeorites. Ascending, we pass through the plane of the rings. We decide to actually fly through a less dense part of the rings, for science's sake. As we approach them, they go from being an ethereal band to a tangible field of glittering ice and rock chunks, ranging from dust grains to boulders. We weave carefully through, watching countless icy rocks spin around us in the lamplight of our vessel, like flying through a crystal snowstorm in slow motion. Each particle shining, some clinking gently as they bump. Though soundless in vacuum, our instruments pick up vibrations. We don't linger too long to avoid collision risk, but it's another unforgettable perspective, seeing the rings from within when we have just seen them from afar. Now, leaving the rings and the planet behind, we once more accelerate outward. The ringed planet, its moons, and the kind sun that illuminated them shrink away. We carry a sense of completeness. We have seen a system's beauty, both up close and from its moon's eyes. Our journey resumes its outward trajectory, and ahead of us lies one of the most mysterious destinations possible, a world circling a black hole. It's a journey to the brink of the unknowable, where starlight bends and time itself might play tricks. With hearts brimming with both awe and a touch of trepidation, we set course for that next bizarre world, ready to venture where very few have dreamt to go. We venture now to a realm of darkness and gravity beyond anything we've encountered, a planet that orbits a black hole. Far from the gentle lights of stars, this world circles the ultimate cosmic abyss. As we approach, the usual cues of a solar system are absent. There is no bright star growing larger, no stellar beacon to guide us in. Instead, we navigate by the distortions of starlight, the way background stars warp and smudge into arcs, as if seen through a curved glass. That tells us the black hole is ahead, bending the fabric of space-time and the light within it. The black hole itself, of course, is invisible against the black of space, a disk of nothingness. But around it, we see a breathtaking phenomenon, an accretion disk, or perhaps just a glowing halo, if the black hole is relatively quiet. In this case, let's imagine a smaller black hole with minimal accretion. Not a quasar engine, but still the gravitational field is immense. There might be a faint accretion disk from interstellar gas it captured, a thin ring of hot gas swirling, emitting a dim ruddy glow or X-ray flashes. More prominently, we see the gravitational lensing effect, a circular ring of smeared starlight surrounding the black hole, known as an Einstein ring, created by the black hole's gravity, distorting the light of whatever lies behind it from our view. Our destination, the planet, announces itself first via gravity as well. Our instruments detect the tug, and visually we pick up a small crescent shape against the backdrop of the star field. It's lit weakly by a distant star. Perhaps the black hole has a companion star that is the source of some light, or maybe distant stars are providing slight illumination. We realize this planet is in perpetual darkness, except for faint starlight and any glow from the accretion halo. It might have once orbited a star that the black hole captured or consumed. It's a wonder the planet still exists at all. Perhaps it formed around the black hole from residual material. Or it's a wandering rogue planet that got trapped in orbit. We descend to the planet's surface. It's rocky and barren at first glance, a bit larger than Mars, perhaps. There's barely any atmosphere. If there was, the black hole's radiation, or the initial supernova that formed the black hole, likely stripped much of it away. The ground is cold, covered in what looks like a thin layer of frost or ice in places. This could be outgas material that froze out, maybe carbon dioxide or other volatiles. What strikes us is the sky. An alien night sky, even darker and richer than what we saw on the rogue ocean world. Here, the constellations are bizarrely warped. Directly overhead, if we assume we land on the side of the planet facing the black hole at the moment, we see a circular patch of starless black. That's the silhouette of the black hole. Around it, the lensing effect creates a donut of light. We can see on one side of the black circle a concentrated smear of light, as if part of the Milky Way got stretched into an arc. That's gravitational lensing magnifying and bending the galaxy's light. It's perpetually night here in a sense. There is no sun, but that doesn't mean total darkness. The galaxy's light itself, particularly with gravitational lensing, provides a faint illumination. Our eyes adapt, or our suit visors amplify. We find that we can actually see the immediate terrain in a monochromatic way under the gentle galactic light, like how on Earth a moonless night still has some sky glow. Additionally, the black hole's accretion halo, if any, is like a dim, eerie light in the sky. Perhaps a thin ring of reddish or bluish light around the blackness. It might be very faint to the eye, but sensitive cameras pick it up. We walk on the planet's surface, which feels still and dead. The gravity is moderate, if the planet is Earth-sized or smaller. With no atmosphere to scatter sound, it's practically silent, except for the crunch of our boots on regolith and our own breathing. There might be occasional tremors. The black hole's tidal forces could cause quakes if the planet isn't entirely geologically dead. We do feel at one point a slight rumble, and a distant fissure cracks, releasing some gas or dust. Evidence the black hole's gravitational gradient is flexing the planet as it orbits, possibly in an eccentric orbit. We decide to climb a nearby ridge for a better vantage. The low gravity makes it easy to scramble up. From the ridge, we get a broader view, a plain dotted with craters, and maybe the glint of ice in them. Far-off mountains that could be ancient volcanoes now frozen in time. And above it all, that cosmic spectacle of the black hole's distorted sphere. We sit and let our eyes wander over the sky. The longer we look, the more we notice. There, that cluster of stars is actually our home galaxy's centre, lensed into a loop. Over there, perhaps the faint glow of a nebula, turned into a smeared streak. Time behaves oddly near a black hole. We know that clocks here run slower relative to far away, due to gravitational time dilation. Not enough to notice at our distance. We're orbiting at a safe distance, not at the event horizon or anything extreme. But theoretically, if we spent many years here, we'd be younger relative to outside. It's the stuff of deep physics, but on a practical level, the main sign is the intense gravity gradient. If we had extremely precise instruments, we might detect that time at our feet, closer to the black hole by a meter or two, runs slightly slower than time at our head. But that's an imperceptible effect for us directly. One thing we do perceive physically is the black hole's tidal gravity on our body. It's subtle, but we feel just a tad heavier on the side of our body facing the black hole than the side facing away. It could be imagination, but such differences can exist near massive objects. Given we're not too close, it's probably negligible though. We check the horizon for the black hole's companion star, if it exists. Perhaps this planet orbits the black hole, which is itself part of a binary with a normal star. If so, maybe there's a distant sun low on the horizon, a faint small star providing a glimmer of daylight on one side of the planet. If such a star exists, it might appear as a particularly bright star in the sky. Not too bright, but enough to cast a soft twilight when above the horizon. Let's say there is one. A reddish star, maybe. Far enough that its gravitational effect on us is minimal. It's currently below the horizon, perhaps, leaving us in starlit night. If it were up, we might get a dim, ruddy day periodically, but given the user's instructions, I think they wanted the vibe of drifting in interstellar space with maybe orbiting a black hole. So likely no companion star shining significantly. Maybe the black hole captured the planet alone. We do notice something extraordinary as we look toward where the black hole's disk meets the horizon. The planet orbits quite close, so what we see is starlight from the far side of the black hole being bent around and coming to us. It creates the illusion that on the horizon opposite the black hole, there's a small upside-down view of the other side of the galaxy, a mirage. It's very subtle, but it means you can actually see stars that are behind the black hole due to the light bending around. It's like space itself is wrapping around this place. The cold begins to seep in even through our suit's thermal layers. Our instruments show temperatures near 200 degrees. In shadowed craters, maybe even colder. We head back down the ridge, noting a faint glimmer in the ground. Perhaps some radioactive mineral giving off a tiny glow, or luminescent crystals energized by cosmic rays. In a world with no sun, any light is precious, and maybe some minerals here have interesting properties. We find a small cave or overhang and step inside. Total darkness here. Our suit lights cut through revealing smooth walls. Could be an ancient lava tube from when the planet had internal activity. We float a small drone inside. It goes a short way and finds nothing but some frozen volatiles. In such a cave, one might hide from radiation or micrometeorites. If some hardy life existed, maybe microbial, existing off geothermal heat or chemical energy, it might hide here. But frankly, the odds of life here are slim. This is more desolate than Mars or the Moon, with perhaps heavy radiation from the black hole's occasional X-ray flares. Climbing out, we see a sudden streak of light across the sky, a meteor burning up, possibly debris being pulled off some other object and falling into the black hole, briefly igniting, or a small asteroid hitting this planet's thin atmosphere. Hard to say, but it was there for a second. A line of white that then vanished. Our time on this dark world has been contemplative. It's a place of silence and extremes, yet not without beauty. The strange optical effects and the utter clarity of the cosmos above make it a unique vantage point. We feel a tinge of melancholy leaving. Who knows when we'll see the likes of such a sky again? We launch off the surface gently, easy in low gravity. As we ascend, we look down one last time. The terrain falls away into gloom. The black hole's shadow on the planet becomes visible. Yes, part of the planet is literally in the black hole's umbra, a round patch of night on the surface that moves as the planet orbits. So weird. A shadow with no obvious caster, except an area of missing stars in the sky. Back in orbit, we take a wide orbit to avoid strong tidal forces and prepare to leave. We accelerate tangentially to escape the black hole's grasp. As we do, we glance at the black hole's immediate vicinity. Inside the orbit of this planet might be other debris, maybe a closer-in planet or asteroids swirling. Closer to the black hole, time and space get stranger, but we stay a safe distance. Now, onward we go. Our ship's path is set to escape this dark system entirely and move into interstellar space again. Our next target is the opposite of this darkness, a free-floating planet out in interstellar space, with not even a black hole anchoring it. A rogue planet, wandering the galaxy alone. Fittingly, leaving the black hole, we now also leave behind the last binding to a star. We set off into the star-flecked void, bound for that solitary wanderer, with the deep quiet of the black hole's realm echoing in our minds. Our ship leaves the black hole's domain far behind, sailing into the vast night between stars. We are bound for a lonely world, a rogue planet, unmoored from any sun, drifting in eternal darkness, except for the far-off glow of distant stars. After some time, hours, days, weeks, in interstellar travel, our sense of duration is fluid. Our sensors pick up the faint gravitational influence and tiny infrared warmth of our target. Against the backdrop of space, which is slightly aglow with the Milky Way, there is a patch where stars blink out, the planet's silhouette. We have found the wanderer. We approach with curiosity and care. This rogue planet is roughly Earth-sized, maybe a bit larger, likely a rocky or icy body that was ejected from a forming solar system long ago. Without a star, it's been cooling for eons, but it might still retain internal heat. It could even have a thick atmosphere or ocean under ice that traps geothermal warmth, making it not entirely dead. Our craft descends toward the dark surface. We turn on powerful forward lights to illuminate our landing zone, as there is no daylight to help. We touch down on what appears to be a frozen lake bed or plain. The gravity is about 0.8 g, indicating a mass somewhat less than Earth's if the planet is similar in size. Possibly a lot of ice content, less dense, or a smaller iron core. We step out into the dark, our suit lights leading the way. The ground is solid underfoot, and mostly flat here, with some gentle rises and depressions. We see our immediate surroundings by our lights. The ground is a mix of ice and rock, with a dusting of what might be snow or frozen gases. No sign of life or movement. The air, if any, is thin and biting cold. We try a small experiment and crack a chemical glow stick, tossing it a few meters away. It casts a green glow on the ground, showing that indeed there's maybe a bit of atmosphere. It doesn't boil off instantly, which is good. The atmosphere could be mostly hydrogen or methane retained from its formation and kept by cold, or it could be outgassed nitrogen. Our instruments confirm a very thin, methane-rich atmosphere with pressure maybe 1% of Earth's. Not much, but enough that over millions of years it hasn't all escaped, especially if the planet has a magnetic field shielding from cosmic rays. Looking up, the sky is starry beyond belief. We thought we'd seen dark skies before, but here, with no sun, no nearby star, and likely fewer human-like dust pollutants. The cosmos is pristine. The Milky Way arcs from horizon to horizon as a glittering river of stars. Other galaxies can even be seen as fuzzy spots if you know where to look. It's the sort of sky that could inspire existential thoughts. Every pinpoint is another sun, and here we are on a world with none. Interestingly, because there's no bright star in the sky, our eyes adjust to starlight itself. The collective glow of billions of stars, especially the dense band of the Milky Way, provides a faint general illumination. It's extremely faint, orders of magnitude dimmer than moonlight on Earth, but given enough time, our eyes, or our suit's low-light amplifiers, can make it usable. So, after a while, we can actually walk around with our lights off and see our immediate environment in monochrome starlight. It is a twilight-like condition, just at the threshold of vision. The snow or ice on the ground helps by reflecting starlight, while the rocks are dark. In this starshine, the landscape looks like an alien dream. Our shadows, yes, we have shadows even from starlight, extremely faint, dance when we turn on our light briefly, then fade when we rely on natural light. We trek a short distance to a higher ground to see if anything stands out. We find something surprising. A gentle blue-green glow on the horizon, like aurora. Could it be? This planet might have auroras from cosmic rays, or if it passes through interstellar clouds with magnetic fields. Also, some of the atmosphere might be fluorescing due to radiation. We approach one of these glow patches and realize it's actually on the ground, a luminescent deposit, or maybe life. Closer inspection shows patches of what look like lichen on the underside of rocks, or in crevices, glowing faintly. This could be chemiluminescent life forms feeding on minerals, perhaps using slow chemical reactions, like terrestrial deep cave glowworms or bacteria, to generate light and energy. It's speculative, but not impossible. On a rogue planet, the main energy sources are geothermal and chemical. If there is life, it's likely microbial or fungal, eking out energy from chemical gradients, e.g. oxidizing minerals, or maybe using cosmic rays as energy. There's research about microbes using radiation as an energy source, though it's exotic. It warms our hearts to think life might find a way even on this lonely world. Perhaps long ago it had life when it was near a star, and after ejection, some adapted to subterranean or alternative energy sources. We kneel and take a sample of the glowing lichen-like stuff. It's cold and slightly waxy. Under the microscope in our lab, it shows a filamentous structure with protective pigments and internal biochemistry that's antifreeze rich. It could be akin to extremophiles from Earth. We can't be sure it's alive, but it's something that organized. Maybe it's just chemical crystals that luminesce, but the pattern and context suggests possible biology. Panning our gaze around, we notice occasional twinkles on the ground beyond our lights. Could be more glowers, or reflections of stars in smooth ice surfaces. Everywhere we turn our light, we reveal a world that superficially resembles a winter night on Earth's Arctic plains. Except no sound of wind, the air is too thin, though there might be a very faint breeze as the planet rotates and differences in temp cause some movement. Actually, the planet may have heat flows that cause an extremely tenuous weather, but at ground level it's nearly vacuum silent. The quiet is absolute, broken only by our own movements. We stop, and just listen. Once our suit fans and hums quiet down, we put them on low for a moment, since external temperature is manageable for a short time. We hear nothing. Maybe a faint cracking of ice as it slowly contracts in the cooling night, though it's always night, but there could be thermal fluctuations from interior heat. We find an interesting feature, a small lake or pond, completely frozen over. The ice has cracked in polygonal patterns, and under it, who knows? Maybe there's liquid. If the planet has internal heat, it could maintain pockets of liquid water under ice, akin to subsurface oceans like on Europa. If so, life might cluster there around hydrothermal vents. We see no easy way to tell without drilling, which we cannot do right now. But we suspect, under our feet, deep down, the core of this planet still retains warmth, or even a magma chamber. That could feed geysers, or at least keep a water table liquid beneath kilometers of crust. We take a moment on the frozen pond to lay down and look straight up at the stars. It's like lying under a crystal dome sprinkled with diamonds. We spot shooting stars, more frequent here than in a typical solar system, perhaps because as the planet drifts, it picks up interstellar dust and debris. They are slow streaks, as the relative velocity is not huge. We also observe that the stars have slight parallax as we move our head. The black hole we left is actually visible as a small gravitational lens distortion in one part of the sky if we know where to look. The galaxy's structure appears slightly different. The absence of a sun makes the constellations more overwhelming. No single star dominates the sky. All are equals, yet the band of the Milky Way is king. After absorbing the profound solitude of this rogue planet, we prepare to leave. Before we do, we set up a small beacon, a kind of cosmic message in a bottle. It will send a ping every so often, a friendly artificial signal, perhaps one day to be heard by any future visitors, or if some evolving intelligence on this planet ever builds radio receivers eons hence. It's our way of saying, you were seen, you were visited, you are not entirely alone in the dark. Boarding our ship, we lift off gently, careful not to disturb too much of the fragile environment. From above, we see our landing site as a tiny speck of light, our beacon, in a sea of darkness. Already frost is forming over our footprints. As we ascend, the rogue planet's curvature becomes apparent, lit faintly by starlight. It's a dark orb with a slight sheen where ices reflect. We fly toward the night side. Well, it's all night side, but meaning the side opposite to the galactic core perhaps, where even fewer stars shine. It's basically invisible. If not for our instruments, we might lose it entirely against space. Now, at a distance, we look at this planet one last time. It's just a black silhouette, outlined by the Milky Way's glow behind it. A lonely wanderer. But in a sense, not utterly lonely. It's embraced by the galaxy's gravitational field, and who knows, maybe it will one day be captured by another star and join a system again, or eventually find its way to the galactic center. We fire up our engines to leave, but slowly, almost reluctantly, as if tiptoeing away. There's a reverence you feel leaving such a place, like leaving a dark, sacred temple. Our journey across bizarre worlds has now spanned from bright stars to utter darkness. We carry with us a trove of memories. Skies with two suns, oceans under alien constellations, the glow of lava, and the whisper of magnetic fields. the silent songs of a black hole, and the tender solitude of a starless planet. As we move on, we realize our part one of this cosmic voyage is drawing to a close. But the voyage itself is far from over. The galaxy is endless, and midnight lies in every direction. Yet so do morning lights around distant suns. In the distance ahead, a subtle brightness appears. Perhaps the combined glow of a cluster of stars, or a reflection from a nebula where new stars are being born. That is where we head next, letting the currents of the galaxy carry us. Drifting onward, we feel the gentle pull of curiosity toward those new lights. The transition from this chapter to the next is seamless, a continuum of exploration. Our craft, like an eternal wanderer, leaves the rogue planet behind, gradually picking up speed, fueled by our longing for more discoveries. The stars ahead beckon with their quiet twinkling. Maybe a young star system with protoplanets awaits, or a nebula of rainbow gases to drift through, or the edge of the galaxy where we might peer out into intergalactic space. Whatever comes, we will greet it as we have all these worlds, with open eyes and a silent awe. And so, with a final glance back, the little beacon's signal winks back at us assuringly. We turn our gaze forward. The cosmic ocean stretches out, dark and inviting, studded with islands of light. Slowly and surely, we set our course for the next leg of our eternal journey, ready to slip into part 2 of this odyssey among the stars, our minds calm and filled with wonder, our hearts beating in time with the quiet rhythm of the universe itself. The universe is vast and filled with wonders beyond our imagination. In the silent depths of space, countless worlds drift and dance, each with its own story. We continue our gentle journey through these bizarre worlds, exploring them with a calm and curious eye. Let us wander further into the cosmic ocean, where ancient planets and strange new horizons await in the darkness. In this second part of our voyage, we will visit lonely planets without suns, moons that circle giant worlds in eternal rhythms, and planets lit by twin suns and twin earths locked in each other's embrace. We will witness alien weather that defies earthly expectations, from glass rains to storms of metal, and stand on the searing surface of inferno worlds and the brittle ice of eternal winter. We will imagine colossal megastructures built by unknown hands, and seek the subtle signs that life might leave in distant skies. Drift with us now, slowly and peacefully, through starry realms and exotic visions. Each world unfolds before us softly, revealing its mysteries in hushed tones. We will journey from blinding eternal day to starless eternal night, from the smallest hints of life to the grandest feats of cosmic engineering, all with a spirit of calm wonder. There is no hurry here, only the endless, mesmerizing wonder of the cosmos to lull us into a state of tranquility and awe. In the darkness between the stars, a lone planet drifts in eternal night. This is a rogue planet, a world without a sun. No dawn ever comes to this wandering sphere. It travels through the cold void, untethered, with only the distant glow of the Milky Way to light its sky. Imagine standing on the frozen ground of this planet, looking up into a sky black as ink. Above, millions of stars spread across the heavens like a pale silver cloud, far brighter than we see from Earth, yet offering no warmth. The air is still and frigid. If there are winds, they whisper quietly over an endless expanse of ice and rock under an everlasting night. Rogue planets are castaways of the galaxy. Long ago, this planet might have formed in a young solar system, circling a newborn star amid a crowded disk of gas and dust. Perhaps a violent dance with giant neighbours flung it outwards, so far that it broke free of its sun's gravity. Or maybe it coalesced alone in the dark, a failed star that never ignited. Whatever its origin, it now wanders alone. There are no sunrises here, no blue skies or soft twilights, only a permanent midnight. Yet, beneath that cloak of darkness, the planet still exists in all its complexity. Mountains of black rock might rise against a starry horizon. Plains of frost extend for miles, their surfaces faintly shimmering under starlight. Every now and then, a shooting star, a meteor from some long-ago comet or collision, silently streaks across the sky, a brief spark in the dark. Despite the absence of a sun, this rogue planet is not entirely without light. If it has an atmosphere, the planet itself might generate a faint glow. Perhaps intense auroras ripple over its skies, fed by charged particles and a strong magnetic field deep within. Curtains of ghostly green or purple light could shimmer over the polar regions, an ethereal dance of light in an otherwise lightless world. These auroras would be the planet's own northern lights, generated not by solar winds, for there is no sun here, but by cosmic rays and the planet's internal magnetism. If one were floating above the planet, looking down, they might see delicate ribbons of luminosity tracing out magnetic arcs in the upper atmosphere, a silent reminder that even in the darkness, beauty can find a way. On the surface, the only illumination might come from the stars and from occasional natural phenomena. Perhaps volcanoes punctuate the night, their glowing lava flows casting a ruddy light on the surroundings before cooling into darkness again. The red-orange glow of molten rock would briefly reveal jagged rocks and frozen plains around the volcanic caldera, then fade as the lava hardens. If the planet is geologically active, such volcanoes might provide transient havens of warmth amid the general freeze. Around these volcanic oases, strange frost patterns might form, where the heat meets the cold, glittering as they freeze under the vast cosmos above. If this rogue planet once had a moon and managed to keep it through its ejection into interstellar space, that moon might hang in the sky as a dark companion. In the faint starlight, it could be just barely visible, a round patch of emptiness blotting out background stars as it moves across the sky. The planet and its moon would orbit a common center, locked in an endless, lonely waltz through interstellar space. Tidal forces between them could stir the planet's interior, keeping its core warm. Beneath the surface ice, there might even lurk a hidden ocean kept liquid by the gentle tug and pull between world and moon. In that lightless ocean, could life survive? Perhaps simple organisms around deep-sea vents, feeding on minerals and warmth, never seeing light but thriving in the heated dark. It is a speculative, almost fantastical idea, Yet on Earth, we find life in the deepest caves and under Antarctic ice, surviving against all odds. So one can wonder, in the deep subsurface of a rogue planet's ocean, might there be tiny creatures slowly living out their cycles, utterly unaware that above them lies an infinite night. Above ground, though, any water would be frozen solid. The temperatures are unimaginably low. Far from any star, this planet's heat comes only from its formation and maybe radioactive elements decaying in its core. Over billions of years, it has cooled. The surface could be near absolute zero in places, cold enough that the air itself, if there was any, has frozen onto the ground. Perhaps a thin atmosphere remains. Traces of gases, like nitrogen or methane, clinging as frost on the rocks each night, which is every night. If you took a step, your foot might crunch on layers of solidified air, the way one might crunch on frozen snow. Silence dominates here. No bird song, no rustle of leaves, no sound of flowing water. If you listen, you might hear only the faint sigh of a distant geyser releasing a puff of gas from the planet's interior, or the creaking of ice as it slowly shifts under its own weight. The silence of a rogue planet is the silence of space itself, profound and undisturbed. As we drift through this eternal night, it's humbling to realize that such worlds may be incredibly common. Astronomers suspect there could be billions, even trillions, of rogue planets wandering our galaxy. Imagine the Milky Way strewn with these dark worlds, like islands in a vast, black ocean. Most will remain forever unknown, nearly impossible to detect against the blackness of space. They carry on through the galaxy's spiral arms, some in perpetual solitude, others perhaps passing furtively through distant star systems before venturing out again. Each one is a silent voyager, a planet without a sun, a world untethered. For a moment, we pause on the lightless plains of our rogue planet and gaze upward. Without a sun, the stars themselves take center stage. The band of the Milky Way is a magnificent arch from horizon to horizon. Dense star clusters and nebulae speckle this band, and with no sunlight to drown them out, even the faintest wisps of cosmic clouds can be seen. Perhaps off to one side, a dim, glowing blotch marks the presence of a nearby galaxy, a companion to our Milky Way, adding its subtle light to the sky. How small one must feel, standing on this world with the universe fully unveiled above. Now and then, this planet's journey might bring it relatively closer to a star or a group of stars, not to be captured by them, but enough that the sky subtly brightens for a time. If it passed through the outskirts of a star cluster or nebula, one might briefly witness a sky filled with multicolored clouds or an unusual density of starlight before the planet carries on, like a ship passing a distant port. It's also possible that one day, far in the future, this rogue planet could be found by travelers or even by us, should humanity venture far beyond our solar system. What a way station it would make in the interstellar void. A solid surface in the emptiness, perhaps even resources hidden under its ice. One could imagine future explorers setting up a temporary camp here, drilling into the subsurface ocean to find water and warmth. creating a little bubble of light on a world that has known only night. In that way, even the loneliest planet might one day feel the touch of life and light again. But for now, we simply drift alongside this dark, wandering world. We appreciate its stark beauty, the glitter of ice crystals under starlight, the soft glow of auroras on the horizon, the unbroken tranquility of a place untouched by any sun's glare. It reminds us that even in solitude and darkness, there is wonder. In the quiet cosmic night, the starless wanderer continues on, a testament to the strange and varied nature of planets. Sometimes, the only hint of life a rogue planet offers is its own internal warmth, a faint red glow from a still cooling core, or a massive body that didn't quite become a star, providing a glimmer of light like a dying ember in the void. Leaving this quiet renegade world behind, we gently turn our attention back toward the light. Not all worlds are so alone in the dark. There are places in the galaxy where multiple lights dance, and where worlds share their skies with giant companions. Our next journey takes us to a very different environment. Not a lone wanderer, but a world that orbits a massive planet, experiencing the rhythms of day and night in a unique way. Our journey now brings us to a moon, circling a vast gas giant, a world that is itself a satellite of an even greater planet. Here, the night sky is dominated by a titanic presence. High above the horizon, a colossal planet hangs, banded with stripes of clouds and crowned by a halo of shimmering rings. This gas giant is the moon's parent, a brilliant globe suspended in the sky, many times larger than the full moon seen from Earth. Its pale light bathes the moon's landscape in a gentle glow. On this moon of a giant, day and night are a dance between the distant sun and the ever-present planet looming overhead. Imagine standing on a tranquil beach by a dark, alien sea. It is dusk. The sky is a deep indigo, and the stars are beginning to appear. The sun, a small bright star in this system's sky, has just slipped below the horizon, painting the clouds in streaks of violet and gold. As the daylight fades, the true monarch of the sky reveals itself. The immense gas giant, rising higher as the sky grows dark. Its rings catch the sunlight still, glowing like a faint opal arc encircling the planet. The giant world's cloud bands are faintly visible, oranges and whites swirled together, and along its terminator line you might catch the sparkle of lightning within towering storm clouds on that distant orb. The air on this moon is crisp and still. Gentle waves lap at the shore, reflecting the giant planet as a broken, wavy ribbon of light on the water's surface. Over the course of the night, the gas giant does not sink or move across the sky as our moon does in Earth's heavens. Instead, if you are on the hemisphere of the moon that faces the giant, that enormous globe remains nearly fixed in place, locked by gravity to always show you the same face. It may bob just slightly with the moon's subtle orbital wobble, but it will not rise or set. You could walk by its light through the night, casting two shadows, one faint shadow from the distant sun's last light, and another, stronger one from the giant planet's glow. On nights when the giant planet is full, its entire dayside lit by the sun, it provides a twilight of its own, illuminating the moon's landscape in a soft, ethereal twilight, even when the sun is gone. But this world's cycle has more complexity than an ordinary planet's day and night. As the moon orbits its planet, sometimes it passes behind the gas giant relative to the sun. At those times, An eclipse occurs. The sun's light is blocked by the enormous planet, and an eerie shadow sweeps across the moon's surface. If you were on that beach during such an eclipse, you would see the sun slowly being hidden behind the curved edge of the gas giant. Day would turn to twilight, and the temperature might drop. Overhead, the rings of the giant world would shine with a ghostly light, reflecting what little sunlight filters around the planet's edges. The sky might take on a dusky, dreamlike quality. For a while, the sun is completely gone, and the only visible light comes from the ringed giant above and perhaps the stars. The giant planet itself becomes a black silhouette, rimmed by a stunning halo of light. The star's corona scattering through its atmosphere and around its limb, like a brilliant outline of fire surrounding a dark disk. In those moments, the landscape would be bathed in a dim, otherworldly glow. Creatures on this moon, if any exist, might grow quiet, waiting for the sunlight to return. And then, as the moon continues along its orbit, the sun reappears from behind the giant, and daylight slowly returns to normal. Such eclipses might happen regularly, perhaps every few orbits, providing a recurring dramatic shift in the moon's routine. On this moon of giants, time is measured in both the orbit around the parent planet and the orbit around the star. Suppose the moon takes about 30 days to circle the gas giant, similar to how our moon takes about a month around Earth. That period would define one day for the moon in terms of sunrise to sunrise, because each orbit around the planet brings the moon back to the same position relative to the sun. So a single day-night cycle here could last many Earth days. During the long day, the sun climbs slowly in the sky, shining alongside the looming face of the gas giant. During the lengthy night, the sun's absence is compensated by the giant planet's presence, which might itself go through phases. Just as our moon shows phases from Earth, the gas giant could appear as a fat crescent, a half-planet, or a full glowing disk, depending on the geometry. When the sun is on the far side of the sky, the giant planet could be fully illuminated, serving as a secondary light in the sky. When the sun is in the same direction as the giant, the planet might appear as only a thin crescent, or even be lost in the sun's glare. The interplay of these lights means that true darkness might be rare. Either the sun or the big planet often provides some illumination. Let us stroll inland from the shore, under the light of the great ringed planet. Tall alien trees with broad leaves, perhaps deep blue or purple to better absorb the star's light, sway gently in a nighttime breeze. They have grown with the presence of two lights in their sky, the sun and the giant. When the giant planet is full, the forest is cast in a silver-orange glow, and you might see shifting patterns on the ground as clouds pass across the giant's face, subtly changing its light. When the giant is new, hidden in darkness during the moon's day, only the sun's light filters through the canopy. These trees likely experience a unique rhythm of growth, perhaps opening their leaves more fully during the long days of direct sunlight, and slowing down during the eclipse periods or long nights when only the giant's glow lights the forest. Perhaps you emerge onto a high plateau where the view of the sky is sweeping and unobstructed. The gas giant looms enormous above, its rings stretching from one end of the horizon to the other like a celestial bridge. Imagine a calm night where you could lie back and observe the heavens. You'd see the constellations slowly spinning, and beyond the rings, perhaps even other moons of the gas giant, glinting as tiny star-like points moving against the starry background. This giant planet may have a whole family of moons. Some of those moons might be airless and cratered, shining bright with reflected light as they race around their parent. Others could be shrouded in ice or clouds. From our vantage point, One of these sister moons might occasionally cross in front of the gas giant, casting a small shadow on its cloud tops, a tiny eclipse on the giant planet itself, visible as a dark spot moving across the planet's face. Conversely, at times, one might see a bright pinpoint of a moon slip in front of the big planet and disappear behind it. The gravitational pull of the giant rules this moon's existence. It causes ocean tides that are far more dramatic than those on Earth. When the giant planet is directly overhead, its gravity tugs at the oceans, drawing them upward. High tides on this moon could send floods of water far upriver, or lay bare vast stretches of seafloor when it recedes. Coastal civilizations, if such existed, might build their lives around the rhythms of both the sun and the giant, perhaps having to move to higher ground during especially strong alignments when the sun and the giant's gravity combine to create supertides. In addition to surface tides, the giant's pull also needs the interior of the moon. With each orbit, the changing gravitational forces flex the moon's crust gently. This could keep the moon's core warm and its volcanoes active. Indeed, some parts of the moon might be dotted with hot springs or gentle volcanic vents, releasing warmth and nutrients. A boon for any potential life. Unlike the rogue planet we visited, here warmth comes not just from the distant sun, but also from the moon's own interior, kept alive by the giant's gravitational embrace. Occasionally, far on the horizon, one might see a glowing red plume if a volcano erupts, reflecting off low-hanging clouds. Ash might drift across starlight, and in the sky, the usually placid face of the gas giant could be joined by a flicker of lightning storms, perhaps triggered by the same gravitational unrest affecting the moon. Yet even these events unfold slowly and majestically. A spray of lava under the alien stars, cooling into black rock. A distant rumble that rolls across the landscape, and then silence again. The stillness returns, and the giant planet gazes down as it has for millennia, a watchful guardian. Living on a moon around a giant must inspire a profound dual awareness. The star that gives life-giving light, and the giant that dominates the sky and shapes the environment. Perhaps intelligent beings on such a moon would have mythology about the great planet above, the way ancient Earth cultures revered the sun or moon. They might see it as a protector or a god looming above, its ring seen as a celestial crown. They would see their sky filled not only with stars, but with a massive, undeniable presence, reminding them always that they are part of a larger system. Standing on a cliff edge, you feel a soft wind and watch as the dawn approaches. The eastern sky brightens with the coming sunrise. The giant planet above begins to pale as the sun's rays scatter in the atmosphere. Soon daylight will flood the sky, turning it a soft blue, or perhaps a different hue depending on the moon's air. The rings will glint with all the colours of the sunrise, rose and gold, before fading from view against the glare of day. But for now, in these quiet moments before sunrise, you soak in the splendour of the cosmos on display, a magnificent gas giant, with all its moons and rings, hanging stationary in the firmament, while meteors from the giant's ring debris occasionally streak overhead, burning up in the atmosphere as brief trails of light. This serene moon, with its giant companion, shows us how varied a world can be. Night here is never just night. It is a partnership between the faint light of a distant sun and the reflected glow of a planetary titan. The sky holds not just points of light, but an immense orb that reminds anyone who looks up of the vastness and beauty of the cosmic neighborhood. As the sun finally peaks over the horizon, we bid farewell to the moon's gentle night. It is time to journey onward. From a world with a giant in its sky, we turn to another remarkable orbital dance, not between stars, but between two planets. Before we explore those alien skies and their exotic weather, let us visit a pair of sister worlds locked in each other's gaze. Floating in the habitable zone of a sun-like star, imagine two Earth-sized planets that orbit one another as they together circle their star. These twin planets are a true celestial rarity, equal partners bound by gravity, each one simultaneously a planet and the other's moon. Let's call them Ara and Bella for ease of storytelling. They dance around a common center of mass, completing a pirouette around each other every few days or weeks, all while journeying around their sun in a larger year-long path. On Ara, the sky is dominated by Bella. It hangs huge and majestic, far larger than our moon appears from Earth. Depending on the distance between the two, Bella might span a significant portion of the heavens, perhaps a quarter or even a third of the sky at arm's length. You could see the details of its surface with the naked eye, swirling clouds, blue oceans, or whatever features it has, since these are two life-friendly worlds. Bella goes through phases, just like our moon, sometimes showing a bright full face when Ara is between Bella and the sun, other times a slender crescent when the geometry changes. At full Bella, the night side of Ara is awash with light. Imagine a night where there is no darkness because your twin planet, fully illuminated by the sun, is hanging overhead like a brilliant disk, casting a silver-blue glow over the landscape. Shadows of trees and hills would be stark under that secondary illumination, and nights would be almost as bright as twilight. During crescent phases, Bella would be a hauntingly beautiful shape, a luminous curved sliver with the rest of its outline faintly visible by the light reflecting off Ara, just as our moon shows earthshine. The gravitational pull between the twins is profound. Tides on Ara's oceans are immense. Not only does their sun tug on the waters, but Bella's gravity raises huge tides that sweep across coastlines multiple times in each Ara day. Coastal civilizations might see the ocean rise and fall by tens of meters. Perhaps vast circular bay structures are carved into continents by relentless tidal ebb and flow. Or unique marine life has adapted to ride these giant tides in daily migrations up and down the shores. On land, the tidal forces could even subtly flex the crust, triggering frequent gentle quakes or volcanism that helps recycle nutrients and warmth, potentially fostering life's diversity. From Bella's surface, Ara would offer a very similar spectacle. Each world likely keeps the same face towards the other, a natural outcome of tidal locking, which would likely occur over time due to their close orbit. That means, from one hemisphere of Ara, Bella is always visible in the same part of the sky, never setting, while the opposite hemisphere might never see Bella at all. In the hemisphere of Ara that faces Bella, the sight of its twin is a constant of the sky, waxing and waning but never vanishing. Perhaps cultures on that side of Ara have woven their myths and rhythms of life around the presence of their sister world, while cultures on the far side have legends of a hidden companion learned of by travelling or from gravity measurements. Likewise on Bella, one side forever has Ara in its sky. When the two planets align just right, they eclipse each other's sun for one another. Residents of Ara might witness a solar eclipse not caused by a moon, but by Bella. Imagine daylight turning to a strange twilight as a large portion of the sun is blocked by the silhouette of your sister planet. During such an eclipse, one might even see the halo of Bella's atmosphere backlit by sunlight, creating a thin ring of light around the dark disk. Perhaps the most awe-inspiring sight would be a double eclipse, Ara, Bella, and the sun aligning so perfectly that Ara falls into Bella's shadow entirely. Then, for a brief period, night falls in midday, a deep eclipse where the stars come out, and in the sky, instead of the sun, you see the night side of Bella, perhaps with the faint glow of its own city lights, if any, or lightning flashes in its clouds. As the alignment shifts, a diamond of sunlight bursts from behind Bella's limb, and day resumes. These events might be rarer, but they would be shared experiences between the two planets, both worlds simultaneously experiencing an eclipse because of each other.
If Ara and Bella both harbour life, they might share more than just an orbit. Meteors knocked off one planet could travel to the other relatively frequently. Early in their history, microbes or spores could have hitchhiked on rocks flung by asteroid impacts, seeding life on the twin, a kind of panspermia between siblings. They might even share similar biospheres or related life forms due to this exchange, effectively making them twin oases of life that evolved in tandem. Perhaps flying creatures could even evolve that can survive short stints in space and travel between worlds. Though that's a fanciful notion, one can't help but wonder what evolution might do in such a close two-world system over billions of years.
For observers on the ground, the presence of a twin planet can influence daily life in prosaic ways too. The night sky, for one, is never truly dark on the near side facing the twin, except during new phase when the twin is dark. Agriculture might rely on the extra light during bright twin nights. Navigators might use the disk of the other planet for orientation as readily as we use the North Star. And psychologically, knowing there is another world so close that you can almost touch it might inspire a culture of exploration like none other. Early astronomers on Ara would quickly figure out that Bella is a world similar to their own. They could likely even see continents or oceans with primitive telescopes. The desire to visit each other would be strong, and perhaps their space exploration is accelerated by the tantalizing proximity of a whole other planet. In time, they could establish communication using lasers or radio as soon as technology permits line-of-sight signaling, which is trivial when your planets are only, say, 200,000 kilometers apart at closest approach. The two biospheres could eventually intermingle deliberately, exchanging plants, animals, knowledge. They would develop a unique relationship. Two planet-wide civilizations growing up side by side, maybe competing at times, but likely cooperating due to their linked fate. Ara and Bella might consider themselves two parts of one whole, a binary planet civilization. For any extraterrestrial observers, the binary nature of the system might be detectable through the wobbles in their orbit or the way they transit their star together, causing unusual light curves. It would surely be a fascinating target for our telescopes if we found such a configuration. We would see the combined spectrum of two Earth-like atmospheres mingled, which could confuse us or delight us with strange readings. Perhaps one day, if we become the explorers, we might find two sister worlds and witness firsthand this beautiful partnership of planets. The existence of twin planets is a reminder that the cosmos allows for endless variations on the theme of worlds. Where one world orbits, why not two in tandem, sharing nearly the same orbit? Their companionship in the void would be a comfort to any beings living there, a constant, shining presence to remind each world that it has a twin it can almost reach out and touch. Now, leaving behind the duality of Ara and Bella, we return to our broader journey. Having imagined the intimate dance of twin planets, we continue onward. It's time to cast our eyes not just on worlds themselves, but on the phenomena that swirl above them. We ascend into the atmospheres to behold the alien skies and strange weather of distant planets, where nature shows creativity that rivals even the wildest imagination. Every world has a sky, but not every sky plays by the same rules as Earth's. Across the cosmos, alien atmospheres brew truly bizarre weather. In these far-off skies, rain need not be water, and clouds come in colours and compositions beyond our experience. Let us gently wander through a gallery of exotic weather phenomena, each a reminder of nature's boundless creativity. Picture a giant planet so close to its star that its dayside temperature climbs above 1,000 degrees. In the high atmosphere of this world, clouds form not from water vapour, but from silicate minerals, the stuff of sand and glass. The result is a deep azure blue sky, coloured by tiny particles of glassy sand suspended in the air. Day and night on this planet are drastically different. On the day side, perpetual glare and heat dominate under a burning sun. But around the twilight edge and into the eternal night side, the fury of the day transforms into something spectacular. Howling winds and exotic rain. As the planet's fierce winds roar from the hot side toward the cooler night side, they carry those vaporized silicate particles with them. In the cooling darkness, the silicates condense into drops of glass. Imagine standing, hypothetically, in a protected capsule in the upper atmosphere at the edge of night. You would see darkness ahead and a glow behind from the day side. Suddenly the wind picks up. A scorching gale, perhaps thousands of kilometers per hour, whipping around the planet's circumference. In that gale, tiny glass droplets begin to form and slash sideways across the sky. It is a rain of glass, each droplet tiny and molten, cooling into a solid shard as it streaks by. These glass raindrops would fall not gently, but driven at incredible speeds by the wind, creating a searing horizontal storm of glittering blue shards. From a distance, perhaps one would see a shimmer in the twilight band of the planet, as countless microscopic glass pieces scatter the fading light, giving the edge of the planet a sapphire sparkle. It's a beautiful yet harrowing spectacle, a storm where the very sand melts and blows in the wind. For any who could witness it safely, the sight would be otherworldly. A blue-black night lit by ribbons of glass rain reflecting star and planet light, the wind screaming above the cloud tops. On another world, even stranger rain falls. This planet orbits so blisteringly close to its star that its day side is like a furnace. Here, the heat is enough to vaporize metals. Iron, that sturdy metal which forms the backbone of our buildings, exists as a gas in the atmosphere of this extreme planet. During the endless day, the sky is a glowing haze of metal vapor and other exotic gases. But when the planet rotates and this atmosphere flows into the night side, it cools down significantly, though still immensely hot by Earth standards. And in those comparatively cooler nocturnal skies, the iron vapor condenses. Imagine nightfall on this hellish world.
As darkness envelops the sky, the air itself begins to sparkle. Tiny droplets of liquid iron form high up and begin to fall. It would be like a molten metallic mist, perhaps at first glowing dull red with heat, then radiating no light at all as it cools further, descending like silvery raindrops. These iron droplets rain down through clouds of iron sulfide and other metallic compounds, a rain shower nothing short of surreal. If one could stand on an observation platform above this world's broiling clouds, one might catch the glint of these iron raindrops in the starlight, or backglow of the dayside, like countless embers being blown from a cosmic forge. By the time they approach the lower layers, they might solidify into tiny bits of iron or splatter onto any surface as cooling metal. In the morning, the cycle repeats. The rising star heats everything. Any remnants of iron rain evaporate back into gas, and the perpetual furnace resumes. The concept is fierce, but there is a strange rhythm to it, a metallic monsoon governed by the cycle of day and night. Not all exotic weather is born of heat, however. Travel far from the warmth of a star, to a cold and dim world orbiting a faint red sun. The sunlight here is weak and ruddy, providing little warmth. The air is frigid, loaded with hydrocarbons. Clouds form from methane, a gas that on Earth we only see as a colourless fuel. But in this planet's gelid atmosphere, methane condenses into thick, orange-tinted clouds. As the clouds saturate, a gentle rain begins to fall, not of water, but of liquid methane. It drips from the sky in slow, fat drops, since the gravity here might be less than Earth's, making the raindrops fall more leisurely. The land below is icy and dark. Great plains of frozen methane and ethane stretch out, carved by ancient rivers of liquid hydrocarbons. In the far distance, low mountains of water ice, hard as rock in this cold, glisten faintly. The methane rain collects in dark, mirror-smooth lakes, filling craters and basins. When a rare beam of the weak sun peeks through the clouds, it reflects off these liquid methane lakes in flashes of dull gold. The smell, were you to sample the air, might be akin to gasoline or other solvents, a chemically rich breeze. Yet it is quiet and strangely peaceful here. The rain falls with a soft patter on the frozen ground, forming tiny rivulets that join into larger streams. Occasionally, a distant roll of thunder might echo, as lightning can still flicker in these clouds, igniting briefly the methane-rich sky with a flash of light. A lightning strike might momentarily set the air aglow in a pale blue flame before snuffing out. The storm passes, and the clouds part to reveal a faint starry sky. On this world, a rainy day is something truly alien. Yet if you closed your eyes, the sound of the rain might oddly comfort you with its familiarity, even though you know it is raining a substance that is a gas back on Earth. And then there are the winds. In some alien skies, the wind itself is the most impressive actor. Consider a tidally locked planet, where one side always faces its star and the other knows eternal night. The contrast in temperature drives colossal jets of wind around the planet's waste. At the terminator, the line dividing day and night, hot air from the bright side rushes violently into the darkness. This continuous gale can reach speeds of several kilometers per second, screaming across barren rock or turbulent seas, dispersing the day's heat into the night. If one were situated at that twilight zone, you would witness an endless storm, a wall of clouds perpetually on the horizon,
marking where the sun's heat meets the night's chill. The wind howls and never ceases. Massive, billowing clouds ride this current, glowing on one side with the light of day, dark and cool on the other. Within those clouds, lightning might dance in unbroken cycles. Flashes illuminate the roiling cloudscapes again and again, soft thunder resonating over the alien landscape without pause. It's a dynamic, never-ending exchange of air and energy, a heartbeat of the planet, felt as a constant, powerful wind. On other worlds, giant storms can take on a life of their own. Jupiter's Great Red Spot is a famous storm in our solar system, a raging hurricane larger than Earth that has persisted for centuries. Exoplanets, especially massive gas giants, could have storms even more titanic. Imagine a striped gas giant with bands of white ammonia clouds and brownish-red hazes. Near its equator, a monstrous vortex swirls, a storm perhaps twice the size of Jupiter's Great Red Spot. It spins with ferocious speed, but due to the planet's scale, from afar it appears almost static, a vast eye in the stormy face of the planet. If we could descend through the layers of this storm, we'd first encounter a roof of high clouds tinted yellow by sulfur compounds. Beneath that, an unending tempest, winds circling at thousands of kilometers per hour, lightning arcing from cloud to cloud. The lightning might be far more powerful than on Earth given the storm's scale. Each bolt a superbolt that lights up an area the size of a small country for a split second. Deafening thunder would follow, rumbling through the dense atmosphere. Though out in space we see only the silent flicker of it. Deeper still, within the bowels of the storm, raindrops may give way to hailstones of water ammonia ice. In some layers, temperatures and pressures could even allow oddities like mushy, hot ice, or perhaps pellets of tar-like hydrocarbons that form in the tumult and then evaporate again in the heat below. Even deeper, carbon atoms might squeeze into crystalline lattices, falling as shimmering diamond rain further down in the crushing dark. Such a storm could rage for ages, fed by the planet's internal heat and the energies of its rapid rotation. Even the notion of a rainbow can take on alien forms in these exotic atmospheres. On Earth, rainbows occur when sunlight is refracted through water droplets. Now, think of a rainbow formed not from water, but from methane rain, or from the droplets of liquid ammonia in a Jovian atmosphere. The colours might shift. Methane absorbs red light, so a methane rain rainbow might be tinted differently, perhaps a band of teal and blue without the usual red and orange. On that ultra-hot planet with iron rain, an observer might not see a human visible rainbow as iron droplets are opaque, but scientists speak of a phenomenon called a glory, a circular rainbow-like halo, which could potentially occur around exotic clouds. Recently, astronomers even speculated about a faint glimmer of a rainbow-like effect in the clouds of an iron rain world, indicating droplets of nearly uniform size, creating a halo of prismatic light high in the atmosphere. Imagine a soft, circular iridescence in an alien sky, not caused by water, but by liquid metal droplets reflecting a faraway sun. One cannot talk about weather without mentioning calm moments too. On many of these worlds, between the storms and extraordinary events, there will be gentle days. Perhaps on that blue glass rain planet, the dayside has calming moments when the star is overhead and the fierce winds die down to upper breezes. The sky, though scorching, might appear placid, deep blue with high silicate clouds shimmering. Or on the methane world after the storm, there could be a quiet dawn with ground mist of ethane swirling over the cold surface, the red sun rising dimly and reflecting off wet surfaces. Even the fiercest of climates have their lulls.
And in those quiet interludes under an alien sky, one could appreciate the foreign yet serene beauty of the environment, be it the oddly coloured clouds, unfamiliar constellations appearing through a gap, or the way the horizon might glow under twin suns after a passing rain shower. Alien weather shows us how varied the cosmos can be. From iron rain to diamond hail, from supersonic winds to colossal everlasting storms, the phenomena are both frightening in power and breathtaking in spectacle. Yet, observing them from a safe perch, one can't help but feel a sense of awe. These distant storms and strange rains are nature's art on a grand scale, patterns of chemistry and physics playing out in far-off skies, beautiful in their own alien way. Having witnessed tempests of glass and rivers of methane, let us move on from the furious atmospheres. Our next journey takes us even closer to the extremes. We will descend to the surfaces of worlds that exist in constant fire or perpetual ice. These are planets at the edge of what a world can endure, true infernos and everlasting winters, as we explore the most extreme environments that still manage to be called worlds. There are planets for which the word scorching is an understatement. These are the inferno worlds, places so close to their suns, or with such intense conditions that their surfaces broil with heat. On such a world, rock itself can melt into rivers. The air, if any exists, is a thin haze of vaporized minerals, and the star looms huge and unforgiving in the sky. Imagine standing on the day side of an inferno planet that is locked in place by its star's gravity. Here, one side of the planet eternally faces the star, baking under unending daylight, while the other side remains in perpetual night. You stand near the center of the day side, at what is called the substellar point, where the star is directly overhead at all times. Above you, the star is an enormous blazing orb dominating the sky. It might appear several times larger in diameter than the Sun looks from Earth, given how close this planet orbits. Its light is blindingly intense, flooding the barren landscape with a white-gold glare. There is no night or shade at the substellar point, no passage of time through day and night, only an everlasting noon. The ground beneath your feet glows a dull red-orange from the heat. It's not just the sunlight making it glow. The rock is literally incandescent in places. Pooled in low spots and craters are vast lakes of lava, shimmering and rippling slowly as the intense gravity and heat keep them molten. Occasionally, a gust of furnace-hot wind disturbs the surface of these lava lakes, sending ripples and waves that splash against half-molten shores. The air around you is a searing blur. If this planet still retains an atmosphere, it might be extremely thin and made up of evaporated minerals and silicates. The landscape shimmers with mirages, heat distortion that makes distant molten flows waver and dance in your vision. If there are any boulders or hills, they are likely covered in a blackened crust that might occasionally crack open to reveal glowing magma beneath, like a cooling pie that's still hot in the center. Perhaps you see the slow bubbling of lava in a nearby pool, releasing a puff of gas or a tongue of flame as trapped volatile compounds ignite upon exposure. On the horizon, toward the edges of this permanent day, the brightness tapers off. If you were to travel away from the substellar point, the fixed sun in the sky would gradually sink toward the horizon. With each kilometre, the heat might lessen slightly. The blinding glow overhead would become more angled, throwing longer shadows from craggy rocks that manage to endure. The terrain could form a gradient, from fully molten lakes and glowing ground at the centre
to a region of semi-molten rock that oozes and crackles underfoot like cooling lava, to areas further out where the ground is mostly solid rock baked into a ceramic-like hardness, etched with deep cracks from the constant thermal stress. In these fringe zones of eternal twilight, the sky would be a deep orange near the horizon, the stars' light scattering through whatever haze is present. Temperatures might still be hundreds of degrees, but perhaps no longer enough to keep everything melted. You might find sharp glassy rocks, solidified lava, and fields of ash or volcanic glass beads that rained out from earlier eruptions. Yes, eruptions. For on an inferno world, the line between planet and star blurs. The star's energy drives the geology. The day side could be pocked with volcanoes that erupt not due to internal tectonics, but because the surface simply overheats and expands, cracking open to vent molten interior. Geysers of lava might occasionally fountain up, spraying glowing droplets that solidify into glass before raining back down. Such eruptions might occur daily under the fixed, relentless sun. Now, if you press on further toward the night side, you approach the terminator, the dividing line between day and night. Here, you might witness one of the starkest transitions in the universe. Standing at the terminator, if you look one way, the world is a hellscape illuminated by a low, fiery sun, with embers on the ground and a sky lit in deep fiery red. Look the other way, into the night side, and you see darkness studded with stars. The ground on the night side is under a black sky, perhaps faintly glowing in places where lava flows from the day side have crept over before solidifying. In the absence of the star's heat, the temperatures plummet precipitously. The rocks that were glowing orange just a few kilometers back are now hard, cold, and brittle. If any atmosphere flows into the night side, it likely freezes out, condensing on the rocks as a thin frost of whatever gases were present, perhaps sulfur or sodium compounds. It might even snow exotic materials as the winds carry vapor from the day to the night. For example, silicon monoxide gas that cools and precipitates as a fine silica dust, coating the night with a layer of glassy powder, reflecting the faint light of the distant stars. The terminator might be a place of constant storm as well. The temperature difference between the blistering day and the frigid night drives furious winds that rush back and forth, similar to what we described earlier on tidally locked worlds. Here, those winds carry dust, ash, and maybe bits of volcanic gas. They could create a permanent wall of clouds or haze that wraps around the planet's twilight ring, marking the boundary between fire and darkness. To step from day into night on this planet would be to go from an oven into a deep freeze in a matter of steps, a journey that no known life could survive, and even machinery would find challenging. Some inferno worlds don't just bake, they boil away. Consider a planet so close to its star that it's literally falling apart under the heat. The rock and metal that make up the planet's surface are evaporating, streaming off into space, and forming a tail like a comet's. Astronomers have detected such phenomena. A planet that orbits its star in just a few hours, so intensely heated that it leaves a trail of dust in its wake each time around. On the daylight side of that world, chunks of its crust likely sublimate directly into vapor. You might envision a scene where the horizon is kind of hazy, not with clouds, but with a continuous sandstorm of pulverized rock lifted off the surface. The star's radiation pressure pushes this material away, and if you were off-planet, looking back, you'd see the planet sporting a glowing tail of particulates, trailing it, like a forlorn flag, signaling its eventual demise. Such a world is ephemeral on geological timescales. In a few million years, it might completely disintegrate, leaving nothing but a cloud of orbiting dust, or perhaps a small metallic core as a remnant. One extreme example among inferno worlds is a gas giant such as Kelt 9b, a planet so hot because it orbits a very bright star extremely closely that its atmosphere reaches temperatures of over 4,000 degrees Celsius, hotter than some stars and hot enough that even molecules are torn apart by the heat. On that giant world, there might essentially be a perpetual glow, as if the planet itself were a dim ember. Its day side could have a faint bluish emission from hydrogen gas heated to plasma states. If we included gas giants in our Inferno tour, we'd find that everything about them pushes the limits. Their clouds are gone, dissociated into atoms. Their night side might still be warm enough to radiate a dull heat glow, and their skies would be an eerie colour of ionized gases. It's a different flavour of Inferno, one of gaseous fury rather than molten rock, but no less extreme. Back on our imagined rocky Inferno planet, let's witness one more event. Starset on the night side. If you stand just a bit into the night side, at the edge of darkness, you could watch the sun permanently fixed at the horizon. It never fully rises, but it also never fully disappears. It just hovers, a blazing presence half below the horizon line. The rocks around you are dark, but the sky to one side is a brilliant orange arch. Perhaps you wait for a long time, and ever so slowly, as the planet orbits the star, if the orbit is slightly eccentric or the tidal lock not perfect, that sun may dip a little more, just enough that for a brief period the night side experiences something akin to a true night. Stars become more numerous overhead, and the furious glow subsides marginally. In that moment, the planet's surface radiates away heat rapidly. You might even see cracks forming in still hot rocks as they cool and contract suddenly, echoing like gunshots across the barren land. But soon enough, as the orbit continues, the sun rises slightly again, or simply stops dipping further, and the permanent dawn returns to the terminator. To an observer in orbit above an Inferno world, the view would be breathtaking and severe. The day side would shine like a dull red coal, with perhaps a glowing halo of atmospheric gases being blasted off into space. The night side would be nearly invisible, except for a faint outline if any volcanic eruptions or cooling lava flows glow at the edges. A long plume of material might trail behind. It would look like a little comet of its own. Against the blackness of space, one could see bright stars and nebulae, but right below, the planet stands out as a half-burning orb and half-inky void. Inferno worlds push the boundaries of what a planet can be. They are sculpted directly by their star's might. Their surfaces and atmospheres, if any, exist in a constant state of flux, balancing on the edge between being a planet and becoming part of the star. In their extreme heat, they remind us of the raw power of suns and the tenacity of matter to still hold together in planet form under such an onslaught. It is a relief, perhaps, to leave these blistering landscapes behind. As we step away from the endless noon of the Inferno planet, we journey outward, far from the star's relentless gaze. Now we venture to the opposite extreme, the realms of eternal cold and darkness. Beyond the warmth of suns lie worlds locked in ice, where light is scarce and time moves slowly under sheets of frost. Let us explore these frozen worlds, the counterpoint to the Infernos, where the beauty is subtle, hushed, and hidden in endless night. Far from the warmth of any sun, there are planets locked in a deep and enduring cold. These frozen worlds exist in perpetual winter, where ice and darkness reign. Here, sunlight is only a feeble suggestion of day, and the stars dominate the sky even at noon. Time seems to slow to a glacial pace on such a planet. Change comes only in the subtlest of ways over eons. Imagine a world orbiting on the fringe of its solar system, perhaps 10 times farther from its star than Pluto is from ours. At high noon, you look up to find the sun, but it is no bright disk flooding the sky with light. Instead, it appears as a brilliant point, scarcely larger than a particularly dazzling star. Its light is pale and cold. You can look around and see your surroundings clearly under this dim daylight. But there is no real warmth to be felt from it. The land is illuminated in a faint bluish-grey hue, as if the whole world lies in perpetual early twilight. All around you stretches a vast expanse of ice. The ground is solid rock, but it's blanketed by glaciers that have grown unimpeded for millions of years. Jagged mountains of ice rise in the distance where ancient ice sheets have collided. The surface of this ice is not smooth like a skating rink, but rough and powdery. In the weak gravity, if this is a smaller than Earth world, and extremely low temperatures, ice can behave almost like rock, hard and brittle. When it cracks, it forms deep crevasses that echo faintly as chunks of ice occasionally break off. If there are plains, they might be covered with layers of frozen gases, perhaps a frosty coating of nitrogen or carbon dioxide snow that precipitated out of the thin air during the long, dark winter. Speaking of air, what might the atmosphere be here? If the planet is large enough, it may have a tenuous atmosphere, but in this cold, much of it may lie frozen on the ground. As you walk, bundled in an insulated suit of course, each step is virtually soundless, muffled by the powdery nitrogen frost underfoot. The air is still and thin, almost unable to carry sound. Your breath, if you could breathe it, would immediately freeze into tiny crystals. With each motion, a small cloud of glittering ice dust may rise and hang in the air, catching the faint sunlight in tiny prismatic sparkles before settling slowly back down. In the sky, halos and arcs of light often accompany the tiny sun. Because the atmosphere is so cold, it is filled with floating ice crystals, what on Earth we call diamond dust. These crystals act like countless tiny prisms. Around the sun, you might see a delicate halo, a ring of light perhaps 22 degrees out, like a pale rainbow encircling the sun. At sundogs, points on that halo, faint patches of brightness might appear if the sun is near the horizon, though here the sun never gets high anyway. These optical ghosts are the only hint of colour in an otherwise monochromatic world. As the feeble sun sets, and on this distant planet a single season could last centuries, so perhaps it's more apt to say as the sun dips below the horizon in a years-long night, the already dim light gives way to true darkness. Temperatures, which were already perhaps 200 degrees, drop even further by a few degrees. Any residual atmospheric gases precipitate out. It might literally begin to snow atmosphere. A fine snow of carbon dioxide or nitrogen could fall from a sky now entirely black, settling on top of older layers. Over time, this builds up strata of different frost, like the rings of a tree marking the passing ages. One layer from a time when the planet was a little closer to the sun, another from a particularly cold epoch. Under the starlight, the landscape glows faintly with a bluish sheen. Ice is a great reflector. Even star glow, though incredibly faint, can cause the ice fields to glint. If there is a moon or two, they might hang in the sky as bright orbs, illuminated by that distant sun. Their light casts subtle moving shadows as they track overhead during the long night. The stars themselves are unwavering pinpricks of light in the crisp air. No twinkle is seen, because the atmosphere is too thin and still to distort them much. Constellations would slowly wheel overhead during the course of the endless night, unless the planet's axial tilt or day length is such that the night persists without rotation, if tidally locked to its star in the far distance, though at such distances tidal locking is less likely. Perhaps this planet is not entirely dead. Beneath kilometers of ice, there could be an ocean kept liquid by the planet's internal warmth, or by tidal forces, if it has a distant massive companion. In that ocean, geothermal vents could create pockets of comparatively warmer water, maybe even nurturing simple life forms around them, but all sealed under an impenetrable ceiling of ice. Once in a rare while, the pressure might cause the ice to crack and release a bit of that subsurface ocean. Imagine standing on the surface when this happens. Suddenly, a fissure in the ice plain some kilometers away erupts with a geyser of water. But in the blink of an eye, as the water meets the vacuum-like cold, it flash freezes. A towering plume of ice crystals shoots upward, glittering like a fountain of stars against the black sky, then drifts back down as snow. The event might be nearly silent, just a soft whoosh and a crackle as the water turns to ice. After the eruption, a new snowfield of fresh, bright ice surrounds the fissure, and maybe a small dome of ice builds up where the water repeatedly oozes out and freezes, creating something like a cryovolcano. Over time, these ice volcanoes form mounds or even mountains, and one might see a ridge in the distance that is actually a chain of ancient cryovolcanoes, long since dormant and now smoothed by ages of deposition. If this planet has any tilt to its axis, or an elliptical orbit, there might be a notion of seasons, though nothing like the Earth's. Perhaps once every long orbital period, it comes slightly closer to its star. The sun grows a bit brighter, still just a larger point, but enough to warm the surface from, say, 220 degrees to 200 degrees. In that relative spring, some of the frozen atmosphere sublimates. A thin fog of nitrogen gas gathers near the surface, and winds start to stir for the first time in decades. It could create a haze that slightly obscures the stars at the horizon, and even generate thin clouds of nitrogen or methane high up. The sky might turn from pitch black to a very dark blue. On the ground, the top millimeter of ice might soften. Perhaps trapped organic compounds, accumulated from meteor infall or ancient chemistry, are released as faint scents or colours in the snow. But this respite is brief and mild, the equivalent of a balmy 180 C afternoon, before the planet swings out once more to the far reaches and everything refreezes solid, the atmosphere falling as snow again, the clouds dissipating, and silence reigning for the long winter night ahead. In these frozen dominions, sound carries differently. There may be moments when the only sound is your own heartbeat, but the ice itself sometimes sings or cracks. On Earth, explorers in polar regions report hearing the ice moan or boom as it contracts in the cold of night. On a whole planet of ice, such noises could be more pronounced, reverberating across the plains. A sudden deep crack forming in a glacier might send a low-frequency thunder through the ground that you feel more than hear. On a still day,
You might notice a high-pitched tinkling sound as well. Tiny ice crystals falling or being blown very gently by a whisper of wind, colliding with others on the surface. A soft, crystalline chime that could be the only hint of movement.
Though these worlds are cold and dark, they are not devoid of beauty. The sky at night is as pristine as one can imagine. With minimal atmosphere, you can see the cosmos as clearly as one could from space. The band of the Milky Way is a blazing river of stars overhead. If the planet lies near the outskirts of the galaxy, perhaps you can even glimpse neighboring galaxies as fuzzy ovals. And then there are the auroras. Yes, even a frozen planet can have auroras. If it has a magnetic field, and there are charged particles streaming from the distant sun or from cosmic rays. Over the poles of the planet, faint curtains of light might ripple. Because the atmosphere is so thin, these auroras might be quite high up, tenuous and delicate. To the naked eye, they might appear as a faint green or violet glow on the horizon, or a diffuse glow overhead that could be mistaken for a cloud. But long exposure or sensitive vision might tease out dancing veils of light, silently moving in the upper atmosphere, painting the dark sky with ethereal colour for hours on end. They would be far weaker than Earth's auroras, given the weak solar wind. But in the perfect darkness of this world, even a subtle aurora stands out. Amid this quiet, eternal winter, life, as we know it, might be hard to come by on the surface. But the landscape itself seems to have a story. Each layer of ice, each frozen lake and cryovolcanic dome is a chapter of eons gone by. Perhaps in some ice layers, one could find trapped ancient atmosphere bubbles, or clues to a time when the planet's star was younger and brighter, and this world not quite so frozen. There is a sense of deep time here. Things change so slowly that a human lifespan is but a flash. A boulder of ice rolled down from a hill might still have its track visible centuries later. Footprints, if you made them, could potentially remain for millennia, only to be slowly softened by the continual settling of microcrystalline ice or occasional dusting of cometary material. Our sojourn on this frigid world draws to a gentle close as we contemplate the majesty of an eternal winter. Though harsh and remote, it offers a profound peace. In the stillness, under an ancient sky, one feels the patience of the universe, the way even a barren, cold world has its quiet cycles and hidden wonders. From the silence of ice, we now turn to some of the most tantalizing mysteries of all, the possibility of life and the markers it might leave on alien worlds. After exploring extremes of heat and cold, of darkness and light, we come to the question, could there be life out there? And how would we know? Our next journey will take us in search of the faint, telltale signs of life, biosignatures, and even beyond, to wonders that might be crafted by life itself in the form of colossal megastructures. But first, let us seek the living breath in the atmospheres of distant worlds. Through all the strange and hostile landscapes we have visited, one question echoes softly. Are we alone? Or do some of these distant worlds harbour life? Life as we know it leaves traces, even if it's just humble microbes or sprawling forests of alien trees. In the vast dark of space, astronomers have begun to look for these subtle fingerprints, biosignatures, the telltale signs that somewhere a planet is not just a barren rock or gas ball, but a living world. Consider what makes Earth's presence known to the universe. If a distant observer with a powerful telescope were watching our planet, they might see hints of oxygen in our atmosphere, a gas that normally wouldn't be abundant without being constantly produced, in our case, by plants and photosynthetic microbes. They might detect methane as well, a gas that on Earth largely comes from microbial life and other biological activity. Oxygen and methane together, coexisting in substantial quantities, is a strong biosignature. Oxygen should quickly remove methane from the air via chemical reactions, so seeing both means something is replenishing methane, likely life. Our hypothetical alien astronomers might also notice the distinctive way Earth's surface reflects light, a sudden change in reflectance in the red part of the spectrum known as the vegetation red edge, caused by chlorophyll in plants. Even without seeing our cities or hearing our broadcasts, they could infer that Earth's air and light carry the imprint of living processes. Now we reverse the role and become the seekers of life. With our telescopes, we gaze at tiny specks of planets, silhouetted against distant stars or glowing faintly by reflected light. We disperse that light through spectrographs and search for unusual patterns in the rainbow of colours. A slight dip here might indicate water vapour. A bump there could be ozone, a form of oxygen that, on Earth, is generated by life indirectly. Perhaps one day we find an exoplanet, maybe similar in size to Earth, orbiting a stable, gentle star. The data comes in, and we see a combination of gases that quickens our pulse, a strong signature of oxygen, and alongside it, methane, and perhaps even hints of other compounds like nitrous oxide or chloromethane, which on Earth have biological sources. No known abiotic process can easily produce this exact mix and keep it constant. It's as if we've heard a whisper from that planet, saying, "Life is here." Let us imagine what that distant living world might be like. Perhaps it orbits a sun smaller and redder than ours, since many stars in our galaxy are red dwarfs. The planet might be a bit older than Earth, giving life plenty of time to evolve. Under the dimmer red-tinted sunlight, photosynthesis might have adapted by using different pigments. Instead of green forests, perhaps you'd find woodlands of charcoal black or deep purple foliage, maximizing absorption of the scarce blue and green wavelengths from the red sun. The air could be thick with moisture, forming low clouds that drape over an emerald, or on this world, onyx-coloured, jungle each morning. Those clouds carry the scent of alien flowers or fungi. Who knows what forms life might take, and then burn off under the shy midday sun, revealing a sky with an orange or pink hue due to the star's light filtering through. Standing in one of those forests, in our mind's eye, we might see broad, flat leaves quivering in a gentle breeze. Strange stalks or blossoms with iridescent patterns catch the faint light. Perhaps small creatures flutter through the canopy, their movements slow and deliberate in the heavier gravity or denser air. On the ground, a carpet of soft, moss-like organisms spreads, each patch a slightly different hue depending on the minerals beneath. Every now and then, the ground trembles slightly. Could be the distant footfall of a large animal, or just the internal geology adjusting. It's hard to tell. But one thing is certain.
this planet feels alive. The very air is rich in oxygen, produced by countless tiny life forms, exhaling the waste gas of their metabolism. A waste gas that, for us, would smell fresh and vital. Of course, we do not truly know what alien life would be like. It might be familiar, using carbon and water and DNA-like molecules, or it could be utterly exotic, though the environments we've discussed lean towards the former. But the beauty of looking for biosignatures is that we're not trying to catalogue the creatures themselves. We're listening for the chorus of an active biosphere. It's like hearing the hum of a distant forest without seeing the individual birds and insects. The collective song is evident in the atmosphere's chemistry and the slight seasonal changes in a planet's appearance. Seasonal changes. Yes, if a planet is alive, it might literally change colour with seasons. On Earth, for example, vegetation blooms in spring and summer, changing the overall greenness visible from space. On a living exoplanet, perhaps when its northern hemisphere tilts toward its star, vast blooms of plankton spread across its oceans, subtly altering the ocean's colour, or the amount of reflective cloud produced above those waters, or continent-sized swaths of vegetation might shed leaves or dry out in a winter, changing the reflectivity, albedo, of that hemisphere. Advanced telescopes in the future could, in principle, observe such changes in the light curve of a planet over its year, a breathing, living rhythm, the heartbeat of a biosphere. Another sign we might look for is the presence of liquid water, often considered a prerequisite for life as we know it. Already, scientists can detect the glint of oceans on some exoplanets, a polarization, or a specific shine in the light indicating a mirror-like reflection, likely from a vast body of liquid. If we see an exoplanet that shows evidence of an ocean and an atmosphere with oxygen and perhaps clouds of water vapor, we become very excited. We can envision that ocean, perhaps teeming with microbial life, or maybe larger creatures gliding through alien seas. On some nights, those seas might themselves glow. On Earth, we have bioluminescent plankton that make the waves shimmer blue. Imagine an entire coastline on an exoplanet sparkling green under a foreign sky, as organisms light up the shallows. We wouldn't see that directly from across light years, but knowing an ocean is there lets our imagination fill in the blanks. Sometimes the search for life takes us to unexpected places. We often think of temperate Earth-like planets, but life might surprise us. It could lurk in the clouds of a gas giant, floating microbe-like forms feeding on chemical energy. It could exist under the ice of a frozen world warmed by geothermal heat. Those would be harder to detect, since they might not change a whole atmosphere noticeably. Yet, our first hint of extraterrestrial life might come in a subtle way. Perhaps we'll see a peculiar ratio of certain gases that just doesn't make sense geologically. Or we might detect a surface pigment that has a sharp spectral edge, like the way chlorophyll absorbs red light strongly but reflects infrared, creating that red edge. In an infrared map of a planet, that edge might stand out as a sudden change at a certain wavelength, a possible sign of widespread photosynthesizers. Let's imagine that moment. After years of observation and maybe a bit of debate, scientists announce that a particular planet, many light years away, shows strong evidence of life. The world itself might have a catalogue name like Kepler 186f or LHS 1140b, but beyond the dry cataloguing, humanity might give it a more poetic name meaning Eden in some language, or dawn. We aim our instruments and perhaps even send probes or signals in our dreams toward it. Knowing that across the gulf of space there is a living planet can profoundly change one's perspective. That night, you step outside and look up at the stars, and you know which tiny point of light is the star of that living planet. It twinkles innocently, one among billions, but you now know that around it circles a place with blue oceans and soft rains, or crimson forests and misty valleys, or endless amber plains under an alien sun. You might never go there, and they, whatever they are, might never know of us. But in that knowledge lies a sense of companionship in the cosmos. Life, even simple life, might give a world a certain aura of warmth in our minds. The universe suddenly feels less cold when we know life flickers somewhere else. It's a connection, however tenuous, a shared phenomenon across light years. The same chemical processes that pulse in our blood, that cycle in our air and soils, are happening on that distant world. Perhaps they have their own equivalents of forests breathing in carbon dioxide and releasing oxygen, or reefs exhaling sulfur compounds into the sea, or microbial mats that churn out methane in marshy lands. We should also consider that finding life signs is just the beginning. Once we know where life is, the desire to know what that life is like will burn brighter than ever. But for the purposes of our gentle journey, perhaps it is enough to know that life can happen, and has happened, beyond our little earth. It is a comforting thought. The universe is not a barren void, but a garden with seeds sprouting in more than one corner. It stirs a feeling of belonging to a greater tapestry of existence. Before we drift too far into daydreams of alien civilizations, remember that all we have, so far, is a spectral line here, a hint of gas there. We have not yet seen incontrovertible proof of life beyond Earth, though now and then a provocative hint stirs debate, such as an unexpected chemical in a distant planet's sky. Not yet. But the stage is set. Our tools are improving, and the cosmos is waiting to divulge its secrets in due time. The search itself has a serenity to it, patiently sifting through faint light, looking for a gentle sign that somewhere, under an alien sky, microbes are metabolizing or plants are growing. It's a quiet scientific vigil, like listening for a distant echo in a canyon. Our exploration of biosignatures prepares us for one final leap in this journey. We have imagined life's traces in the air. Now we turn to consider something even more extraordinary that life might do. Given enough time and advancement, life, in the form of intelligent civilizations, might reshape worlds or build structures on a cosmic scale. These would be the ultimate signatures of life, not just chemical hints, but monumental architectures silhouetted against starlight. As we move into our final chapter, we will gently speculate about such megastructures, colossal constructions that may orbit stars or drift in space, and what they would mean for those who find them. So let us leave our living planet with its softly breathing forests and move into the cosmic workshop of possible cosmic architects. Not all wonders in the galaxy are born of nature. If a civilization becomes advanced enough and ambitious enough, it might create structures so vast that they rival planets in scale. These megastructures would be the ultimate expressions of intelligence.
engineering projects on a stellar canvas. They are theoretical for now, but scientists and dreamers have pondered them. Dyson spheres that encase stars, ring worlds that spin around suns, or other colossal constructions orbiting in the dark. To encounter one would be to realize unequivocally that we are not alone, and that minds capable of reshaping worlds have left their mark on the cosmos.
Picture approaching a distant star system. From afar, the star's light is unusually dim, as if a veil covers it. As you draw nearer, the reason becomes apparent. Encircling the star is a vast spherical shell, or perhaps a dense swarm of structures that captures most of the star's light. This is a Dyson sphere, a concept imagined by physicist Freeman Dyson in the 20th century. The idea is that an advanced civilization might build a huge collection of solar panels or habitats completely around their star to harvest its energy. Instead of letting the star's energy dissipate into space, they would use it to power whatever grand existence they have. From the outside, such a sphere might look dark, since it absorbs the starlight. You might only see a faint infrared glow as the waste heat is re-emitted, the hallmark of a star that isn't shining as it should, as if wrapped in a warm blanket. Now imagine crossing the threshold and entering the interior of a Dyson sphere. The sight would defy comprehension. You are now inside a hollow shell that could be the size of Earth's orbit around the Sun, a sphere with a radius of 150 million kilometers. That's a structure with an interior surface area billions of times larger than Earth's. The inner surface of the sphere is the habitable side, curving up from the horizon and ultimately arcing overhead. The landscape wraps all the way around until it meets itself on the opposite side. At the very center of this sphere hangs the star, no longer distant in the sky, but fixed at the center of everything, pouring out light and heat to all directions. There is no night on a classic Dyson sphere, unless the civilization has engineered something like adjustable panels or an inner day-night cycle. Perhaps they have, to simulate a cycle for the life living on the interior. Or perhaps the beings here have grown accustomed to perpetual daylight. As you stand on the inner surface, you see terrain rising in the distance. That is actually the sphere's inner wall curving upward. If the sphere is rotating, though a Dyson shell wouldn't need to rotate for gravity, it could use the star's gravity, but let's imagine a variant that rotates. You might feel a sense of down being towards the hull, allowing people to walk on it as if it were ground. Far, far away, so distant that atmospheric haze blurs it. The surface curves overhead. With a telescope, or perhaps if you travel far enough, you could look up and see what lies on the opposite interior side of the sphere. Maybe it's ocean or continent, or a patchwork of habitats and technological arrays. The scale is so immense that clouds might form near the star, like tiny bright points near the sun, and drift downward toward the interior surface below. Water might be an enormous supply, perhaps lining parts of the sphere's interior as curved seas. Water would naturally collect at the lowest point of gravitational potential, which, depending on rotation or design, might be the mid-latitudes of the sphere if spinning is involved. One could have a continuous ocean girdling the interior, or perhaps many separate lakes and seas held in basins engineered into the shell. If the builders wanted night and day, they might place a series of gigantic panels or mirrors orbiting the star inside the sphere, casting moving shadows. Perhaps great rectangular night ships orbit close to the star,
blocking its light in sweeping patterns so that different regions of the sphere experience night for a number of hours. From the surface, that might appear as a slow-moving eclipse that rolls across the sky, giving relief from the endless noon. When the shadow passes, morning comes again as the star's light floods back. Think of living inside such a creation. Your sky is not the cosmos, but the interior of your world curving up. The concept of an over-the-horizon is entirely different. If you trek far enough, you could theoretically come back around beneath your starting point, travelling inside the sphere. Perhaps throughout the interior there are artificial suns, secondary sources of illumination or heat for specific regions, or colossal towers that connect the inner surface to structures closer to the star. The technological details boggle the mind, but from our perspective, what a serene and surreal environment it could be for its inhabitants. A near-infinite landscape, bathed in starlight, perfectly controlled climate, if they desire, and room for trillions of individuals or countless ecosystems, all living on the inner shell of a world of their own making. Of course, not all megastructures need to be full spheres. Some theorists imagine Dyson swarms or Dyson rings, myriad satellites orbiting in a dense formation around the star, each collecting solar energy. From far away, a Dyson swarm might partially dim the star in irregular ways. One possible explanation thrown about for the mysterious flickerings of Tabby's star was a partial Dyson swarm, though natural explanations eventually gained favour. Inside a swarm, it might not be as awe-inspiring as a solid sphere, but you'd have an orbit filled with countless habitats or stations. If you were living on one of those habitats, you might sometimes see other habitats glinting in the distance, perhaps like slow-moving stars across your sky as they catch the light of the central sun. Communities could exist on separate platforms, yet trade and travel between them, like an archipelago in space. The light from the star could be regulated by each habitat with shutters or by moving in and out of the most intense beams. Another elegant megastructure concept is a ring world. Imagine a band completely encircling a star at roughly Earth's distance, rotating to create artificial gravity on its inner side. A ring world is like taking a slice of a Dyson sphere around the equator and making it into a huge ribbon. The famous science fiction vision of this has towering walls at the edges to hold in atmosphere. On the inner surface of the ring, you have a single, continuous planet surface that goes on forever, or eventually loops around. Day and night could be generated by placing giant panels or moons that orbit the star and cast moving shadows on the ring. Standing on a ring world, the view in one direction would be a horizon curving up to your left and right, and if you looked far along the ring, you might see it narrowing in perspective until it's a line, then eventually above you, a thin, bright curve. The far side of the ring, hundreds of thousands or millions of kilometers away, shining with reflected daylight. The ring would produce a sky much like a normal planet, blue perhaps, with clouds, assuming atmosphere, but with the peculiar sight of land very high above at the edges, if you could see that far. At night, when the shadow panels eclipse the sun for your section of the ring, you might actually see lights or glowing cities far up on the inner curve of the ring, if the civilization has settlements all around it. It would be as if the entire horizon rose up and encircled you from great distance. Now, how might we detect a megastructure? One way is the star's light, as mentioned, an inexplicably dim star, or one with odd periodic dips in brightness that don't match planets. We might detect unusual infrared radiation, a sphere or swarm absorbing starlight and re-emitting heat would glow in infrared wavelengths. In fact, some searches have been conducted scanning the skies for the signature of
too much infrared around certain stars, which could hint at something like a Dyson sphere. So far, none clearly found, but a few interesting candidates always spur debate. Another clue could be if we directly imaged a system and saw a dark circle where a star should be, or a ring-like structure. That would be unmistakable, a silhouette of a megastructure.
Imagine the day we find such a thing. A star, say 200 light-years away, shows a strange spectrum and slight gravitational wobbles that hint not at planets, but at some huge orbiting mass distribution. We get time on a next generation space telescope, and an image comes through, a dark circle with a bright dot in the center where some sunlight escapes, or perhaps a crescent of light if it's a partial structure. It would be perhaps the most groundbreaking discovery in human history. We would know that a technological species managed to survive long enough to embark on a literally astronomical engineering project. It might even be millions of years old. Perhaps the builders are long gone, and the sphere or ring is a relic still orbiting silently, a ghostly shell around its star. Or perhaps it's maintained, home to beings who might or might not even remember what a natural planet is like, beings who live on a construct that to them is simply the world. Such a find could be as eerie as it is exciting. If the structure appears abandoned, say the star is leaking light in places, implying meteoroid impacts have punched holes in the sphere, or parts of the ring are missing, one can imagine a profound stillness around that star. The megastructure drifts on, empty, like a derelict cathedral in space, the star continuing to shine into the remnants of what was built around it. What stories would that structure tell? Was it a utopia that failed, or a project completed and then evacuated for reasons unknown? Or is it perhaps still full of life, but a kind we cannot communicate with yet? From a distance, we might only observe and wonder. Perhaps we send a probe, knowing it won't arrive for centuries, and in the meantime, all we have is the knowledge that the universe harbors not just simple life, but intelligence that is literally engineered on a solar system scale. In more optimistic pondering, maybe such megastructures are not rarities, but somewhat common for advanced societies. If that were true, the galaxy might have many stars with faint infrared glows, each indicating a civilization managing its star's energy. They might be quiet, peaceful civilizations that long ago solved scarcity by harnessing their star, and now live inwardly on their vast constructs, contemplating philosophy, art, or pathways to even greater adventures like moving galaxies that takes us to almost unimaginable scales. Or they might use their megastructures as arcs, carrying entire ecosystems. One could even imagine mobile megastructures, like a stellar arc that can move out of its system, effectively a roaming habitat the size of a planet, or bigger, sailing the galaxy. Speculation aside, the presence of a megastructure would be a silent but unmistakable beacon. Intelligence was here. Unlike a radio signal, which is fleeting, a megastructure could endure and be detectable for eons. It's like a great pyramid or monument, visible long after the civilization itself might have changed or gone. Let's envision one final scenario to gently close our journey. We are aboard a small exploratory vessel, and we have discovered a Dyson sphere around a quiet star. We find an entry point, perhaps a large circular portal that the builders left open for spacecraft to come and go. We glide through this portal and inside, and are greeted by the sight of the interior civilization, or its remains. We decide not to disturb anything. This is just a reconnoiter. We skim just above the inside surface, passing over what looks like continents and oceans laid out below. The light from the central star bathes everything in a perpetual late afternoon golden glow. Perhaps the sphere's material has dimmed the light to a comfortable level. We see geometric patterns down there. Could be cities, or former cities. We notice gigantic towers that might be support structures or elevators rising inward toward the star, perhaps to facilitate travel or energy transfer. The sheer scale, thousands of kilometers of tower, dwarfs anything we know. As we quietly traverse this space, we might reflect on the journey we've taken tonight, from lonely rogue planets with faint auroras, to moons with giant ringed planets in their skies, to double star sunsets, storms of glass and iron, molten landscapes and frozen vistas, the subtle exhalations of life on faraway worlds, and now this, the handiwork of minds bridging the gap between planet and star. The universe suddenly feels at once immense and intimate. Immense in its variety and scale. Intimate in the sense that even across light years, we've found things that spark our recognition and imagination. Each world, natural or artificial, has been a chapter in a grand cosmic story. In the hush inside the Dyson sphere, our vessel coasts without a sound. We decide it's time to leave, to let this marvel continue its orbit undisturbed. We exit back through the portal, once again in open space, with the stars' faint glow behind us. Out here, the night is deep and comforting. The stars, innumerable points of light, surround us, each one potentially harboring bizarre worlds, or life, or perhaps other megastructures. Our journey has been but a sampling, and there are infinitely more wonders out there. As we drift away from the monumental sphere, we cast one last glance back. The star is barely visible, just a dull warmth behind the dark construction, a cosmic lantern enclosed. Around us the galaxy stretches, and a gentle darkness fills the spaces in between. In this moment of stillness, we feel a profound sense of calm. We carry the knowledge and wonder of these bizarre worlds within us, like treasured dreams. Now, as the stars wheel slowly by, and our voyage through imagination comes to rest, we can close our eyes. The universe will continue to sparkle and surprise, crafting and hosting wonders beyond counting. In the peaceful darkness, we let these images of strange, beautiful worlds lull our minds. Each planet, each sun, each silent megastructure is a lullaby from the cosmos, reminding us that even in the vastness, there is so much to explore and so much to dream about. While we sleep, those distant worlds will continue their celestial ballet, unfazed and eternal. In that knowledge, we too can let go and drift, carried by the gentle rhythm of the cosmos, into a deep and peaceful slumber under the watchful glow of the stars. Good night and sweet dreams.